I think we have not finished second chapter fully.
Coordinate compounds, no? The last part of second chapter is. We finished that, no? Ammonium and hydronium. That's the end of the chapter. Okay, we'll see that later. It's done actually. Maybe you were absent or something. Yeah. All right. Turn your cameras on, all of you. Now, previously we have learned that any compound is generally made up of a positive and a negative radical or an ion. Okay, there's a positive ion and a negative ion. So if the positive ion is a metal and the negative ion is a non-metal, then what type of a compound is this? Huh? Tell. It's a salt. That's what he said? Then what he said? It's actually not covalent, it is ionic compound or electrovalent compound. That's what we studied from the previous chapter, okay? So now what we are seeing here is if the positive ion is a metal and the negative ion is a non-metal, then that compound is a salt. And the bond between this is what type of bond? Ionic bond or an electrovalent bond. Okay. Now, if the positive ion is replaced with hydrogen, negative is same, non-metal itself. But if the positive ion is replaced with hydrogen, then this is what? This is an acid. You understand what's an acid? Acid is a compound where the positive ion is hydrogen. Negative will always be non-metal. Okay. Now instead of now leave the positive ion as metal itself, but the negative ion instead of a non-metal you put OH. Then that becomes a base. You understand what's an acid and a base now? An acid is a compound where the positive ion is hydrogen. A base is the compound where the negative ion is OH. Okay. Okay. Now H is called the hydrogen ion, and OH is called what? Hydroxide or hydroxyl ion. You're calling it ion, then it is hydroxyl ion. Now, what is an alkali? So any base that dissolves in water, it's an alkali. Okay, so these are the simplest definitions for what is a salt, acid, base, and alkali. What is the chapter's name? Acids, bases, and salts. Good. Okay, you understood what is the three? What's an acid, everyone? The positive ion is negative is non-metal. What's a base? Where the positive ion is metal, but the negative ion is OH. And what's a salt? Positive is metal, negative is non-metal. Okay. Now let's look at the definition in the book for what an acid is. An acid is a compound which, when dissolved in water, yields hydronium ions as the only positively charged ions. So this is your acid, H with the non-metal. When you put this acid in water, this H and the non-metal will separate. Okay, you'll have hydrogen ions and the non-metal ions. Now what this hydrogen ions will do? It will join with the water. H2O will join with the H plus. And what will this become? It becomes H3O plus, hydronium ion. Okay, let us see an example of that. Anyway, that is what an acid is. Acid is a compound which, when dissolved in water, yields hydronium ions as the only positively charged ions. Tell me an acid now. There are three very strong acids. What are those acids?
Sulfuric acid.
Yeah, the three acids are HCl, the three strong mineral acids. Okay, means they're not from any living thing. HCl, H2SO4, and what? HNO3. Hydrochloric acid, sulfuric acid, and nitric acid. So let's take HCl as our example. So what does this definition say? If you mix this in water, you mix it with water, first what will happen is the HCl will get dissociated, which means you will have H plus and Cl minus ions. And the H2O is also there. This H plus will join with the H2O. H plus will join with the H2O and form H3O plus. This is called the hydronium ion. So the definition of acid says that when all this happens, hydronium ions will be the only positive ions in that solid, in that acid. Was there any other positive ions? Actually, hydrogen is a positive ion, but that hydrogen joins with the H2O to form hydronium ions. Everyone clear? Now, what's a base? A base is a compound which reacts with hydronium ions of an acid to give salt and water. Okay. So they're using the definition of base. I mean, they're explaining the definition of a base by using an acid. So they're saying that if you take a base and react it with this hydronium ion, you will get salt and water. So they're describing the neutralization reaction. What's the neutralization reaction? We've learned neutralization reactions. Anyone remembers what that is? Neutralization, neutral, tell. And yes, only one person remembered. Acid plus base gives salt and water. Okay, so here they're saying that base will join with this hydronium ion, which came from the acid, right, to give salt and water. This is the definition for a base. It reacts with the hydronium ion to give salt and water. Okay. Uh, the examples of bases are any oxide or any hydroxide. Not only hydroxides, but also oxides. So zinc oxide, lead oxide, copper oxide, iron oxide, sorry, iron hydroxide, lead hydroxide, copper hydroxide. They're all bases. Okay. Finally, what is an alkali? What is an alkali? A base that dissolves in water. There are only four alkalis. Okay, there are two strong alkalis, that is NaOH and KOH. Sodium hydroxide and potassium hydroxide are the strong bases. So all our for all our reactions and everything, we'll be using these two. Okay, and there are two weak bases. The weak bases are calcium hydroxide. What's the formula for calcium hydroxide? CaOH twice, because the calcium's valence is 2 plus. So crisscross method, the 2 comes for OH. And the other one is ammonium hydroxide. What's ammonium hydroxide? It was there in the second chapter. Ammonia is NH3. Ammonium is NH4. So ammonium hydroxide, NH4OH. Both of them have a valency of 1. Okay, so we don't have to put any 1 or 2. Okay, so these are the weak alkalis. Okay, so now tell me which are the strong acids? HCl, H2SO4, and HNO3. They are the strong acids. And which are the strong bases? When we talk about strong bases, we are talking about strong alkalis, because we need to dissolve the base in water for the reaction to take place. And the only two bases which will dissolve in water and form a strong base is NaOH and KOH. So they are like the strong bases of the strong alkalis. Okay, this much is clear, everyone? Now, there are some not very important things in this chapter. That is classification. Classification of acids and bases. So you're classifying acids based on their source. So you have organic acids and inorganic acids. Organic acids are from living things. So what are the acids from living things? That's from plants like citric acid, oxalic, tartaric, and acetic acid. Have you heard of any of them? Where do you find citric acid? All citrus fruits, like lemons and sweet lime, orange. Okay, they have citric acid. How's the taste? Sour. The taste of acids is sour. Whatever acid it is, it's sour. What is acetic acid? Have you heard of acetic acid? The la-
Vinegar.
It's vinegar. Acetic acid is vinegar. Okay. All right. Then inorganic acids are not from plants or animals. They are from minerals. Means you get them from nature, from rocks or whatever. You make these acids using some other elements. So these are the three inorganic acids, and we know that they are very strong. Okay. Next is on the basis of molecular composition of the acids. Molecular composition means whether they have oxygen in them or no oxygen in them. So hydracids have no oxygen in them. It is just hydrogen with a nonmetal. HCl, HBr, HI. Oxyacids will have hydrogen, a nonmetal, and oxygen. So, for example, HNO3 and H2SO4. Right? They have hydrogen, they have a nonmetal like nitrogen or sulfur, and they have oxygen. Not very important part. Next is on the basis of strength of an acid. So, in acids, we have strong acids and we have weak acids. Strong acids and weak acids. You know the strong acids? Those same three. HCl, H2SO4, HNO3. Weak acids, there are many. Okay, acetic acid, citric acid, carbonic acid, formic acid. Most of them are organic acids, right? They are weak. What do you mean by strong and weak now? How can you say one acid is strong, one acid is weak? We take an example of HCl. Okay. Now, if you put HCl in water, if you dissolve HCl in water, what happens to HCl? When you put an acid in water, what happens to that acid? Okay, it becomes dilute, but what is happening to H and Cl? It separates, it dissociates. That's what we saw before this, right? See, we saw the same thing here. HCl in water, what happens? It separates into H and Cl. Okay. Now, the strength of an acid depends on the concentration of these H plus ions. If if it's almost completely dissociated, that means if almost all the HCl molecules will separate into ions. HCl is a molecule. When HCl separates, it forms what? Ions. H plus ions and chloride ions. So if there is, say, more than 70% of HCl has separated into ions, then it's a strong acid. If less than 70% of the HCl has dissociated, then that's a weak acid. So the strength of an acid depends on what? The concentration of the hydrogen ions. Is that clear? Say there are 100 molecules. From the 100 molecules of HCl, say 80 molecules got dissociated, which means you have 80 hydrogen ions. So is that a strong acid or a weak acid? It's strong. It's because more than 70. The number 70 is not here in your book, but I've seen it somewhere. Okay. Now, say there's another acid like weak acid. Look at this. CH3COH. Okay. Now, CH3COH does not dissociate completely, or only partially, less than 70%. So it dissociates, see, from CH3COO minus and H plus ions, but very less amount of H plus ions. So since the concentration of H plus ions is very less, this is a weak acid. Is it clear, everyone? What is a strong acid and a weak acid? So if you see in the book, it will be written like this. What is a strong acid? It is an acid which dissociates almost completely in the aqueous solution. Means when you put them in water. What's a weak acid? Which dissociates only partially in the aqueous solution. So producing a low concentration of hydrogen ions. In strong, you will have a high concentration of hydrogen ions or hydronium ions. Hydrogen, when it joins with water, it forms the hydronium ions, right? So if you have a high concentration of hydronium ions, it's strong acid. In a weak acid, you will have a low concentration of hydronium ions. Any doubt in what is a strong and weak acid? Is it clear, everyone? Same thing for alkalis also. Okay. Now, if you take an what?
Explain strong and weak again.
Strong acids will have a high concentration of hydronium ions. It will dissociate almost completely. Okay, you'll have a high number of hydrogen ions. So it is the hydrogen ions that make an acid strong. So more hydrogen ions means more stronger acid. Lesser hydrogen ions means weak acid. Okay. For alkali also same thing. Now these are the two strong alkalis, right? Sodium hydroxide and potassium hydroxide. Now here also when you put them in water, what happens? They will separate into sodium ions and hydrogen hydroxide ions, hydroxyl or hydroxide ions. So if there's a high concentration of hydroxyl ions, then that's a strong alkali. If there's a low concentration of hydroxyl ions, it's a weak alkali. So it depends on the dissociation. More dissociation, more hydroxyl ions, strong alkali. Less dissociation means less amount of hydroxyl ions, weak alkali. Is everyone clear with this or not? So you have to just remember what are the strong acids and the strong alkalis, because that's what we do all reactions with. How many strong acids do we have? Three. How many strong alkalis do we have? Two. Which are the two? NaOH and KOH. Okay, you all write down this much now. I'll just first you write down what is this? Salt, acid, base, and alkali. What have I highlighted over here? What is this? What do we see here? Huh? Acid in water, and acid is getting dissociated. The HCl is getting dissociated into what? Hydrogen ions and chloride ions. In the next step, the hydrogen ions is joining with the water to form hydronium ions. Okay. So anyway, main thing what's happening here is the dissociation of HCl. Now here what I've highlighted here, same thing but for alkali. So NaOH with aqueous means what? Mixed in water. So instead of putting plus H2O, I just wrote AQ. It's the same thing. Even here I didn't have to put H2O and H2O. I could have just written HCl will become H plus Cl. Understand? So here also same thing. NaOH, when you dissociate, when it's dissolved in water, it dissociates to form sodium ions and hydroxide ions. What's a strong acid, everyone? A strong acid means
Hydrochloric acid.
yeah, almost complete dissociation of HCl to form a high concentration of hydrogen ions. What's a strong alkali? Again, same thing. Almost completely dissociating to form a high concentration of OH minus ions. The neutralization reaction is a reaction where you see all these three, the topic, or your chapter's name is acids, bases, and salts. Right? If you react an acid with a base, you will get salt and water. That reaction is called a neutralization reaction. Why do we call it a neutralization reaction? Why did they use that word? Neutral. What's the meaning of the word neutral? Hmm? Neutral means what?
Stable.
If you drive a car or a bike, then you know neutral gear is what?
So when on neutral gear bike on neutral, if you accelerate, it will not move.
Yeah. So neutral means it won't go front, it won't go back. It's on nothing. It's
Yes.
right. So same here also. This reaction is called a neutralization reaction because when you mix an acid, the acids are very strong. With a base is also very strong. But when you join them both together, you're getting something like salt. It is not strong. It doesn't harm anyone. It's not. It doesn't have that strong properties of an acid or a base. So where's the acid gone? It's gone. Where's the base? It's gone. Okay. You've got a neutral substance here. Yeah, that's why it's called neutralization reaction. What is that? Lightning? No, no. Okay. Okay. Next, Classification of acids and bases is based on the amount of water, just the amount of water that you add. So what if you take HCl and you add a lot of water to HCl? Now what happens to that acid? It becomes dilute, right? The meaning of the word dilute means there's a lot of water. What's the opposite of dilute? Concentrated. So concentrated acid means there's a very less amount of water in it. There has to be water because only if there's water, these hydrogen ions will join with that water and form these hydronium ions. And the acidic property depends on the hydronium ions. Okay, so water has to be there. But if there's less water, then that's a concentrated acid. And if there's more water, then that is a dilute acid. Okay. The next topic I will just explain to you in less detail, and the next class I will explain to you that in more detail. Okay. The next topic is the basicity of acids and the acidity of bases. And they've mixed up the words. Okay. For acids, we call it basicity, and for bases, we call it acidity. Okay. It's very simple. The basicity of acids just means the number of hydrogen ions present in that acid. Okay. So if there's only one hydrogen ion, then that's a monobasic acid. If there are two hydrogen ions, dibasic acid. And if there are three hydrogen ions, tribasic acid. Okay. So give me examples of monobasic acids. HCl, HNO3. What about the CH3COOH? Here, how many hydrogen ions are there? Only this last hydrogen is the one that is going to dissociate. Okay, so there's only one hydrogen ion.
Yes.
Okay, the other CH3, this H3 is not what makes it the acid. Okay, that is part of the negative ion. There are more monobasic acids like HBr, HI, hydrogen bromide, hydrogen iodide, and hydrogen chloride. From the hydrogen chloride is the strongest. Is everything clear? Monobasic acid. Remember the word, okay? Mono means one, and basic because it's called basicity. So monobasic acid. Then dibasic acid will have two hydrogen ions. Examples are H2SO4 and H2SO3. What is the difference H2SO4 and H2SO3? What is H2SO4? H2SO4 you all know. Sulfuric acid. What is H2SO3? Sulfurous acid. Okay, that's not very strong. And then you have H2CO3. What do you know about H2CO3? Carbonic acid. That's what we drink in soda, right? Soda is carbonic acid. So it's not a very strong acid, right? And then lastly, you have tribasic acid. So three hydrogen ions. There's only one example. That is H3PO4. Okay. The reactions we will see in the next class. Now, same way for bases also you have monoacidic base, which means it has one OH. So NaOH, KOH, NH4OH. There's only one hydroxide ion. Then diacidic base will have two hydroxides, like calcium oxide and calcium hydroxide and copper hydroxide. And then triacidic base is like aluminum hydroxide and ferrous. Ferric, actually, this is ferric. Okay, anyway, it is iron hydroxide. So they have three hydroxide ions. Is everyone clear on this? I'll give you a compound. You tell me what it is. Whether it's a out of these six, we have six here, right? Three on the left, three on the right. So I'll write the compound here. You tell me what it is. Okay. What is H2CO3? Dibasic acid, right? What is AlOH thrice? Triacidic base. Okay. What is HNO3?
Monobasic acid.
Monobasic acid. What is CaOH, what is it? Twice. What is this?
Diacetic base.
Diacetic base. Okay. So you all understood this? We'll continue with chemistry and maths in the next class. Okay. I'll see you all tomorrow. Bye, everyone.
Bye, sir.
Okay, so what we have seen is a monobasic acid, when it dissociates, it produces one hydrogen ion, and this whole thing happens in one step. Here we saw how a monobasic acid reacts with a base, and this hydrogen and sodium gets replaced. Sodium joins with the NO3, hydrogen joins with the OH. Okay. Now we're going to see a dibasic acid. Okay, tell me a dibasic acid. Speak loud. Tell me. You tell. H2SO4. What is H2SO4, Leah? Sulfuric acid. So when you put the sulfuric acid in water, what are you supposed to get? You're supposed to get two hydrogen ions, right? Because sulfuric acid has two hydrogen ions. But the thing here is, you don't get two hydrogen ions in one step. Okay. First, only one of the hydrogen ions will get dissociated. And then afterwards, the second hydrogen ion also will get dissociated. So dissociation of both the hydrogen ions will not happen at the same time. That is the thing over here. So in the first step, only one hydrogen ion is removed from here. So you have H plus, the remaining is HSO4. Did you see how it separates? The H2SO4 separates into, first it becomes H plus and HSO4. Out of the H2SO4, only one hydrogen separates. The remaining hydrogen is still attached with the SO4. You get it? And there's the water. So this hydrogen will join with this water in the next step to form H3O. Okay. Then in the second step, you have still HSO4. You have still one hydrogen that is attached, which is the negative ion now. Here again, this will join with another water molecule. And in this step, this hydrogen also will separate from the SO4. So you'll get another H plus with the SO4 minus. Okay. So what we see here is the dissociation of sulfuric acid takes place in how many steps? In two steps. In the first step, only one hydrogen is separated or dissociated. In the second step, the second hydrogen gets dissociated. So you're getting two, how many hydronium ions? First, you have one hydronium ion, which is 3O, and in the second, you have another hydronium ion. So each molecule of sulfuric acid is able to produce two hydronium ions. Is that clear, everyone?
Yes, sir.
Okay, write this down first. Okay, listen now. Now in your book, you will see written slightly differently. You won't see the H plus written separately and the H2O written separately. It will be joined. So tell me that reaction. H2SO4 plus H2O, what will it produce? You're just showing how this one hydrogen from here goes and joins with the water. So what will that form? H3O plus HSO4 minus. Okay. And in the next step, you will show how this HSO4 minus joins with the second water molecule. So here also, this hydrogen from here will get dissociated and go and attach with that water. So that will form H3O plus and SO4. Oh, and by the way, SO4 is 2 minus. See, it was already 1 minus here. And when that hydrogen left, it became 2 minus. Here HSO4's valency is what? 1 minus. And when this hydrogen left, it became 2 minus. Is that clear? If you write these two reactions together in one step, that will be H2SO4 plus how many waters? This one sulfuric acid molecule is joining with two water molecules to produce how many hydronium ions? Two hydronium ions, H3O plus and one SO4, 2 minus. What is it? What is Okay, so this is the complete reaction. Even though we have written it as one reaction, does it happen in one step? No, it's happening in two steps. These are the two steps, but we are just writing them as one step. In reality, it happens in two steps. So how can you control how many steps it should happen in? Like, what if you only want the first step to take place? Okay, it's based on the temperature you give. For all these reactions, you have to give certain temperature. Okay, so if the temperature is low, then only the first reaction will take place. If you increase the temperature a little more, then the second reaction also will take place. Is that clear? You'll be seeing this in another chapter later on, similar type of reaction, okay, where they control the temperature and they're able to control how much of the reaction takes place. If the temperature is low, what will happen, Aman? Can't hear you. Fan is louder. Tell. Why? It will combine with water. The hydrogen has to combine with water. Only then it becomes acidic. But only one of the hydrogens will combine with water because only one of the hydrogen will get dissociated. If the temperature is high enough, both the hydrogens will dissociate and join with water to form two hydronium ions. Okay, write that now completely. All right. So when an acid reacts with a base, when H2SO4 reacts with a base NaOH, first reaction is one of the hydrogen from H2SO4 will get exchanged or will displace the Na from here. Or how do we say this? Okay, just tell me what will happen to H2SO4. Take off one hydrogen and put one Na over there in its place. So what will this compound become? NaHSO4. Right. Out of the H2, one hydrogen is gone and one sodium came over there. And what will this OH become now? Hydrogen joins with the OH and forms huh?
H2O.
H2O. Okay, so this is the first reaction. Now in the second reaction, uh, okay, uh, again we are seeing this H2SO4. Think of it like this. This is the reaction that takes place when there's a lower temperature. Okay, and when there's a higher temperature, what will happen? So H2SO4 will join with NaOH this time. But here, what will happen is both the hydrogens will get displaced by two sodiums. So see, when you're taking out two hydrogens, you need to replace it with two sodiums, right? So what will this form now? Or you can think of it like this. Look at this. From here, now you take off this hydrogen and put one more sodium. What will that form?
2NaSO4.
Na2SO4. See, first there was two hydrogens. Take off one hydrogen and put a sodium over it. It becomes NaHSO4. Then in the second step, you take off that hydrogen also you take off, and you put one more sodium. So that will become Na2SO4. Okay. Plus H2O. 2H2O to balance it. Okay. So here acid plus base gives what? Salt and water. Now,
Salt.
what is the salt that we got over here? See, this salt is not a normal salt. A normal salt is only supposed to have a positive and a negative. Okay. Here, this salt has positive sodium, negative SO4, and what is in between? There's a hydrogen in between. So this salt is called an acid salt because of the hydrogen in between. Okay. This salt that we get is an acid salt. And in the second reaction, the salt we get is a normal salt. A normal salt just has a positive ion and a negative ion, no hydrogen, no OH. An acid salt will have hydrogen in between the positive and the negative, between the metal and the non-metal. Okay. So when any dibasic acid dissociates or reacts with a base, you get two salts. You get an acid salt and a normal salt. Clear? So what we have seen as a dibasic acid produces two hydrogen ions in two steps. That is the gist of this whole thing. A dibasic acid will produce two hydrogen ions, not in one step, but in two steps. Next, we'll go to a tribasic acid. So what's a tribasic acid? That we have only one tribasic acid is there. What's a tribasic acid? Phosphoric acid. So H3PO4 is the tribasic acid, H3PO4. So first, if you mix it with water, what do you get first? One hydrogen joins with the water to form H3O plus, and what will happen to H3PO4? Becomes H2PO4, 1 minus. Then next step, that H2PO4 will join with another water molecule to form the second hydronium ion and HPO4. This one's valence will be 2 minus because it's losing one hydrogen every time. And in the third reaction, you get HPO4, which is 2 minus, this is 1 minus, that will react with another water molecule to form another third hydronium ion and PO4. And its valency will become 3 minus because it lost 3 hydrogen ions. Is it clear? If you write all these three in one step, how will it be? H3PO4 joins with how many water molecules? 3 water molecules to form how many hydronium ions? 3 hydronium ions and PO4, 3 minus. Okay? Try writing it without looking.
Anna,
Yeah.
could you explain it again? I got disconnected actually while you were explaining.
A tribasic acid gets dissociated in 3 steps. So it produces 3 hydronium ions one step at a time, not all 3 together, one after the other. Okay. So first time H3PO4 will become H2PO4. Then it becomes HPO4. And finally it becomes PO4. Every time losing one hydrogen. And as it's losing one hydrogen, its valency will become from 1 minus, 2 minus, and then 3 minus. In short,
Okay, Anna.
a tribasic acid will dissociate in 3 steps, not in 1 step. Now we'll see the same thing, this H3PO4 reacting with a base, which base again will take NaOH. So what will happen in the first step when one hydrogen is, when sodium is replacing that one hydrogen? So what will you get? Remove one hydrogen and put NaO there. So NaH. How many H? Because there were 3, only one of them is getting displaced with this sodium. So NaH2PO4. That H goes and joins with OH to form water. Right? Okay, this is the first step. What type of a salt is this? It's an acid salt because you have the sodium which is positive, the PO4 which is negative, and then you have two hydrogens in the middle. So this is an acid salt. Next time this H3PO, next time it is not H3PO4, it is actually NaH2PO4. Okay, but we are writing the whole H3PO4 joining with 2 NaOH. This is the step. So here you'll have Na.
H.
Will replace two hydrogens. So Na2 goes here, and how many hydrogens are remaining? Only one. So Na2H PO4. 2H2. And in the last step, if all three hydrogens are replaced with 3 NaOH, then what do we get? If all three NAs goes and replaces all the three hydrogens, we'll get Na3PO4 with 3 water molecules. Okay, so how many salts are we getting here? We're getting 3 different salts. First salt is acid salt. Second salt, that also is acid salt. And the third salt, that is a normal salt. So 2 acid salts and 1 normal salt. Clear, everybody? Write this down. Okay, so we're done with acids. Okay, a monobasic acid will dissociate in how many steps? 1 step. The dibasic acid will dissociate in 2 steps, and a tribasic acid will dissociate in 3 steps. Now, coming to bases, it's not like that. Whether it's a monoacidic base or a diacidic base or a triacidic base, it will all dissociate in 1 step. It happens at the same time. Okay, so I'm not writing this, but look here. The first monoacidic base you have is the simplest one, that is sodium hydroxide. When it dissociates, it becomes Na plus and OH1 minus. Right? It dissociates positive and negative ion. A dibasic acid like calcium hydroxide will also dissociate in 1 step itself. It forms Ca2 plus and 2OH minus. And a triacidic base also, AlOH3, it will dissociate to form what? Al3 plus and 3OH1 minus. The thing is, how many steps it takes to dissociate. So for all bases, they all dissociate in 1 step. For acids, they dissociate based on the number of hydrogen ions. Is everyone clear with that? Okay. Any doubt?
Region.
Yeah. All right. We'll pause with the chemistry for now. Rejoin the meeting and we will do maths. Okay. All right. Anyway, the next topic is preparation of acids and bases. This is very important. You have a lot of chemical reactions. From now on, you'll be seeing so many chemical reactions. Okay. So what all is there? Preparation of acids and bases. Then properties of acids and bases. Then there's acid rain. Okay, that's an interesting topic here. Okay, let's see what all is there in this chapter. Then what is a neutralization reaction? What's a neutralization reaction, everyone? Acid plus base joins to give salt and water. Then you have another interesting easy topic, that is the indicators. Indicators are what helps you to differentiate between an acid and a base. Okay, if I give you some liquid here and tell you what is this, you might not be able to tell. But if you have an indicator is simply like on paper. Put the paper in the liquid that I gave you and it will change color. So depending on what color is formed, you can tell whether it's an acid or a base. Okay, so there are different indicators. We'll be seeing that over here. Different types of indicators. These are the color changes. How does the indicators work? So they depend on pH. You know, acids have a pH. What's the pH of acid? Have you heard of pH? Okay,
Yes.
okay, if you don't know. And then you have salts. Okay, that's the next topic, salts. All about salts. You have preparation of salts. That is the biggest topic in the chapter. Preparation of salts. Okay. All right. So let's begin. One of our acid is less than 7, right? Okay, so pH, how does it work? It's a scale. Okay, the pH scale is from 0 to 14. 7 is in the middle. 7 is neutral. Okay, if the pH is 7, it means that substance is neutral. So water generally has a pH of 7 because it's not acid, it's not base. If the pH is less than 7, it's acidic. And if the pH is more than 7, it is basic. Okay, the farther away from 7, the more stronger it is. So if the pH is 6, it means it's slightly acidic. 5, more acidic. 4, more acidic. So 1 will be the most acidic. And base is also same way on the opposite. 7 is neutral. 8, 9, 10, 11, 12, 13, 14. 14 is the most basic. Okay, so coming to preparation of acids. So look, first acids. Uh, we already know that an acid is made up of hydrogen and a non-metal. We saw that in the beginning, right? Did we? What is an acid? Yeah, hydrogen plus non-metal. Where is that? See here, acid. Hydrogen plus non-metal. So there are two types of acids. There is some acid with just hydrogen and that one non-metal, or sometimes there's acid with hydrogen, a non-metal, and oxygen. Right? Okay. So first we're seeing just the normal hydra acids. Hydra acids means which only has hydrogen and the non-metal. So example is hydrogen chloride and hydrogen iodide. So to make this is very simple. It's just H2 plus Cl2 will give HCl. This is direct combination. Okay. In the same way, bases also like sodium oxide and magnesium oxide. Remember, bases are they could be either oxides or they could be hydroxides. So here these two bases, sodium oxide. How do you prepare sodium oxide? Just that sodium metal, you're reacting with oxygen. And magnesium oxide also direct magnesium plus oxygen. Okay, the second one is from acidic oxides. So acidic oxide plus water gives you an acid. First of all, what is the meaning of an oxide? Anything that has oxygen joined with it, like carbon dioxide, sodium, sulfur dioxide, sulfur trioxide, phosphorus pentoxide. These are all oxides. What are these names? Tell me. Carbon dioxide, sulfur dioxide, sulfur trioxide, phosphorus pentoxide. Okay. So we agree that they're all oxides because there is oxygen. But why do we call it acidic oxide? Huh? They form acids. When you mix them with water, see, they're all gases, okay? When you dissolve these gases in water, what do you get? You get acids. That's why these oxides are called acidic oxides. Okay, so let's see what are the acids formed. Carbon dioxide plus water forms carbonic acid. Sulfur dioxide plus water forms sulfurous acid, SO3. And sulfur trioxide plus water forms sulfuric acid. Remember these two reactions, they will come in acid rain. Okay, sulfurous acid and sulfuric acid. And then phosphorus pentoxide, when you dissolve in water, you get phosphoric acid. Okay, so out of these four acids, which is the strongest acid?
Sulfuric acid.
Sulfuric acid.
Sulfuric
Acid. You all know sulfuric acid. You have a chapter on it. Okay. What are the three strongest acids? Sulfuric, nitric,
HCl, hydrochloric acid, sulfuric acid,
and nitric acid. Yeah.
hydrogen.
So hydrochloric acid, see that we already made here. See, the direct combination. The second strongest is sulfuric acid. That is made from an acidic oxide. And then you have nitric acid. Let's see if that is here. No, you're using nitric acid. Okay. Anyway, the preparation of all this you will learn in detail in that chapter. In HCl chapter, you will learn the preparation of HCl. In H2SO4 chapter, you learn preparation of H2SO4. Okay, not one preparation, many methods you learn. Laboratory preparation, industrial preparation, second laboratory preparation. Okay, all that you learn in that chapter. Okay, now you're just learning in basic. Okay, like just the reaction. Whole process you will learn later on.
No, my school is doing H2SO4.
Oh, you're already there.
Yeah.
So you learned something called contact process and all that, right? Do you know?
Yeah. I gave a test today about contact.
Good. Okay. All right. Now coming on the right side, bases also can be produced from basic oxides. So again, these two are basic oxides. First of all, why are they oxides? Because they have oxygen. Potassium oxide and sodium oxide. They have oxides. I mean, they are oxides because they have oxygen. Why are they called basic oxides? They form base when you join them with water. Right. So potassium oxide plus water forms potassium hydroxide. And sodium oxide plus water forms sodium hydroxide. Now these, sometimes they call them as bases. Sometimes they just call them as basic oxides. See over here, see, sodium oxide, we can call them either as a basic oxide or a base. See, the metal itself directly reacts with water. Instead of the metal oxide, the metal directly, like instead of potassium oxide, you can see here what potassium itself joins with water to form potassium hydroxide. Same way, sodium also reacts with water to form sodium hydroxide. Do you remember that video I've shown you when you throw the metal in water, it explodes? That is this metal directly reacting with water. Okay, so these metals are known as highly reactive metals, right? Activity series: sodium, potassium, what else? You know the activity series? We've learned the activity series from the most reactive metals to the least reactive metals. The most reactive is sodium, potassium, calcium. Then you have little lesser reactive, like huh? Zinc, magnesium, aluminum, what? Aluminum, iron, lead. Lead it is. Lead is there or what? Lead is not there, no? I don't think lead is there. And I don't think so. Then you have hydrogen, which comes in between, and below hydrogen, you have the least reactive metals. What are they? Huh? Gold, silver, platinum, mercury, and copper. So below hydrogen, you have copper, then mercury, then silver, then gold, and then platinum at the last. So platinum is the least, in fact, it is non-reactive metal. Okay, so what we're seeing here is that the highly reactive metals, they directly react with water to form the base. Okay, base, and yeah, hydrogen gas also is evolved. The next reaction is salt plus acid. Now, we have seen these type of double decomposition reactions. When did we see this? Eighth. Okay, so let me just give you the summary of all the different types of double decomposition reactions. Double decomposition. So what do you mean by double decomposition is if you have a metal, non-metal reacting with another, okay, let me write it this way. AB reacting with CD to form AD and CB. Okay, why? Why like this? So here A is the positive radical or positive ion, B is the negative radical. Same way C is the positive radical, D is the negative radical. I'll give you an example. Take HCl and the H by BCl is 35. Alexa, stop. Why did it say that? HCl plus NaOH. Okay. Now in this H is the positive and Cl is the negative. Right. In NaOH, Na is the positive ion or positive radical, and OH is the negative radical. Right. So what reaction takes place over here? H is the positive that will join with OH. Positive will not join with positive, right? H will join with the OH and form H2O. And the Na will join with the Cl. This positive will join with the Cl to form NaCl. Now you understand why A joins with D and it's not BC, it is CB. Because you have tried the positive and then the negative. Okay. So this is double decomposition reaction. And there are four types of double decomposition reaction. The first one is called the neutralization reaction. In neutralization reaction, you see an acid plus base gives salt and water. Okay, this is a one of the double decomposition reaction called neutralization reaction. And the second one, there's no name for it, but for those reactions we call them double decomposition. So that is acid plus salt gives acid plus salt. Next one is base plus salt will give base plus salt. And last one is salt plus salt will give salt plus salt. These are all the different type of reactions. Okay, I'll show you examples for each of them. In this chapter, we need to know all these type of reactions. Okay, so we'll see that. But just memorize it for now. What is neutralization reaction? Acid plus base gives salt and water. And then the other double decomposition reaction, first one is acid plus salt gives acid plus salt. Then base plus salt, base plus salt. And salt plus salt will give salt plus salt. Is that clear, everyone? Let's just write down this much first. Yeah, the third one is acids from salts. How can we make acids from salt? Is there any of these double decomposition reaction where we have acids from salts? Here, acids. We can make an acid from salt. So basically, you need an acid plus salt to get a new acid. So this is what they're talking about. Okay. So here, an example is given here. Normal salt, KNO3 plus an acid, sulfuric acid, will give you an acid salt, basically a salt plus an acid. So this is salt plus acid gives salt plus acid. Other reaction? Okay. We're going to write down this reaction now. So what is a salt? So we're taking salt plus acid to form salt plus acid. There's only one condition here, that is the acid that you're producing has to be a less volatile acid. Okay, and the acid that you're using should be a more volatile acid. Now, what's the meaning of volatile? Volatile means unstable. Wait, I think I said it the other way. Here, sorry. Okay, the acid that you're using should be a less volatile acid, and you can only produce a more volatile acid than what you're using. So what's the meaning of volatile again? Unstable. So what happens if you keep an unstable acid outside? It will evaporate. That's the meaning of unstable. Okay, it will easily evaporate. So, petrol. Is petrol volatile or non-volatile? It's volatile. It evaporates. If you leave petrol outside, it immediately starts evaporating. Okay. So in the same way like this. So you need to know which acid is the least volatile and which acid is the most volatile. Have I explained this to you before sometime? Okay. So we'll write down a list of all acids from the least volatile to the most volatile. Least to the most. The least volatile acid is H2SO4. Least volatile means it's the most stable. It doesn't evaporate. It just stays as it is. Okay, H2SO4 is the least. And the most volatile acid that you need to know is H2CO3, carbonic acid. Okay, what is carbonic acid? Soda. You know what happens if you open the bottle? You can it separates. Huh? Separates is gone. That means they separate. What does it separate into? Huh? What does H2CO3 separate into? Water and carbon dioxide. Okay, so it separates, and the carbon dioxide evaporates. It goes into the air. So this is the most volatile acid. Now, in between this, you have HCl and HNO3. Okay. So this is the order of only these four acids you need to know. H2SO4, HCl, HNO3, and H2CO3. From that, the first three are the strong acids. Right. Okay, write down this order of volatility from the least to the most. Done? Why do we need to know the order of this acid from the least to the most volatile acid? Just for this reaction. That is salt plus acid forms salt plus acid. Okay, because we need to know that only using a less volatile acid we can make a more volatile acid. So, for example, suppose you want to make HCl, what acid can you use? If you want to make HCl, you need an acid that is less volatile than HCl. H2SO4. That's the only acid that is less volatile than H2SO4. Same if you want to make HNO3, you can use H2SO4 or HCl. To make H2CO3, you can use any of these three. Understand? So using a less volatile acid, you can make a more volatile acid. Okay. So now look at the reaction over here. H2SO4. From H2SO4, what are they making? HNO3. Is it possible? Yes, because H2SO4 is the least volatile. Right. Yes, same way H2SO4 can also be used to make HCl. Okay. You all rejoin the meeting, then we'll continue with this.
Yes, sir.
So these reactions here, that is acids from salts. Okay, we have seen that we can use sulfuric acid to make both the acids. Hold on. Nitric acid and HCl acid. Okay. So let's write down this reaction. So the salt we're using is either KNO3 or we can use NaNO3. Remember, try to use K and Na everywhere as metals because they are the most reactive metals. So this you have to join it with with H2SO4. And you'll get a double decomposition reaction. That is, the K will join with SO4 and the H will join with NO3. Okay. So when K joins with SO4, what do you get? You actually get K2SO4. Okay. See, when you do crisscross method, K's valency is 1 plus, SO4's valency is 2 minus. So the 2 goes for K and the 1 goes for SO4. So you're supposed to get what? K2SO4, and you will get H when it joins with NO3, you'll get HNO3. Okay. But remember in the previous page, we saw that when acids decompose, especially like dibasic acids, how do they decompose? How do they dissociate? One step or two steps? Two steps, because there are two hydrogen ions, right? And this reaction, what I've written here is the reaction that will take place if both the hydrogen ions get displaced by two potassium ions. Right. See here, how many hydrogens are there? Two. So if both the hydrogens get displaced by two potassiums, like we need two potassiums here, we need to put a two over here, right? Then only this reaction will take place. Okay. Now in the book, what you see over here, they have not replaced both the hydrogens. They have replaced only one of the hydrogen, and that is the reaction that we need. Okay. After writing it, I'll tell you why. So if only one of the hydrogens here gets displaced, then what do you get? Take out one hydrogen and put one K over there. So you'll get KHSO4 plus HNO3. All right. So both these reactions are correct. Okay. The condition is what? If you want only one hydrogen to get displaced, you need to give a temperature less than 200 degrees Celsius. Okay. And if you give more than 200 degrees Celsius, then both the hydrogens will get displaced. Is that clear? You see the reaction in the book. What's the temperature? Less than 200 degrees Celsius. That is why you get only one of the hydrogens getting replaced with potassium. Okay. So both the reactions are okay. Both will produce nitric acid, or both can produce hydrochloric acid. Now, when you go to these two chapters, that is hydrochloric acid chapter and nitric acid chapter, you will realize that they don't use the top reaction. They don't keep the temperature more than 200. They'll keep the temperature less than 200 degrees Celsius. There are three reasons for it. Listen now, when the chapter comes, you'll remember, okay? First reason is saving some fuel. If you want to keep the temperature more than 200 degrees Celsius, you need a lot of energy. So you're wasting fuel. That's one thing. Second reason is that high temperature could break the glass. All these experiments are done inside glass apparatus. And if the temperature is too high, what could happen? You could break the glass. And the third is the most important reason. What does it form? The salt that it forms. Okay. This salt here, KHSO4, that salt, no problem if that salt is formed. But if this K2SO4 salt is formed, it will stick on the sides of the glass. The whole glass apparatus will get stuck with this K2SO4, and once that is stuck on the glass, that whole glass apparatus becomes useless. You have to just throw it. Okay. So you don't want this K2SO4 to form. It spoils the whole apparatus. Okay. So don't keep the temperature more than 200 degrees Celsius. What are the three reasons? First reason is wastage of fuel, energy. Second, you can break the glass. Third one, yeah, this salt. What is the salt's name? Potassium sulfate. We don't want that salt form. Okay. We don't mind the second salt. What is this? Potassium hydrogen sulfate, or short form is potassium bisulfate. In chemistry, the short form for hydrogen is what? Bi. Okay. All right. So that is the reaction we can see over here. Write down these two reactions. Okay, so what we saw here was we saw the first type of reaction, that is acid plus salt gives acid plus salt. And the condition in this reaction was that the acid that you're producing should be more volatile than the acid that you're using. Only one condition. Okay. All right, now we'll go to the second reaction, that is base plus salt will give base plus salt. Now here also there are two conditions. The first condition is same like before, that is the base that you're producing should be more volatile than the base that you're using. Okay, so that is one type of these reactions. But there's another type of reaction also, that is the base that you're forming should be a precipitate. What's the meaning of precipitate? It's just insoluble. It will settle down at the bottom. So look at these reactions here in the book. You can see salt plus base gives salt plus base. But the base that is formed, see the arrow down? That means it forms a precipitate. Okay. Now, how do you know which salt is forming precipitate, which salt doesn't form precipitate? So you need to know which salt or which base dissolves in water and which one does not dissolve in water, right? So this aluminum hydroxide forms a precipitate because it does not dissolve in water. NaCl dissolves in water, NaOH dissolves in water, AlCl3 also dissolves in water. So out of all these, the only one that doesn't dissolve in water is AlOH thrice. How do we know that? You'll be learning that. At the end of this chapter, there's a whole table of soluble and insoluble salts. That is the most hardest thing to learn here. Hardest means you need to spend time in learning that. Okay. So what I'll do is I'll just go down to the end of this chapter and show you the list of soluble and insoluble salts. Okay, here. This is your table here. Okay. So let's just go through this so that we know what is soluble and insoluble. Okay. On the left side, you have all soluble salts, and on the right side, you have all insoluble salts. Okay. So first, all sodium salts, potassium salts, and ammonium salts are soluble. Remember, a salt is made up of positive and negative, right? Okay. So the positive ion, if it is sodium, potassium, or ammonium, then it is soluble. Remaining all the points talk about the negative part. Okay. Only the first point was talking about what the positive ion should be. Okay. Now look at the second point. All nitrates, nitrites are soluble. All bicarbonates, all sulfates, all chlorides are soluble. Now in the insoluble section, you have some exception for, like, in all the bicarbonates are soluble except potassium bicarbonate and sodium bicarbonate. Okay, even though it was written here all sodium and potassium salts are insoluble, this is an exception. Potassium bicarbonate and sodium bicarbonate are sparingly soluble, means they hardly dissolve. If you mix it a lot or if you give a lot of heat, then it will dissolve. Then sulfates. All sulfates are soluble except lead sulfate, silver sulfate, calcium sulfate, barium sulfate. Next, chlorides. All chlorides are soluble except lead chloride, silver chloride, mercury chloride. Lead chloride is soluble in hot water. Then all the remaining salts are insoluble. That is sulfites, sulfides, carbonates, oxides, hydroxides, phosphates are all insoluble. Okay. I'll show you how to memorize this later on. But right now, look at this list and let's compare with what we have over there. So looking at this table, you tell me, is aluminum chloride soluble? So what do we know about chlorides? All chlorides are soluble except lead, silver, and mercury. So aluminum is not coming in those exceptions. So aluminum chloride is soluble. Clear? Next, NaOH, soluble or insoluble? How do we know? Because it's sodium. All sodium salts are insoluble. They have written here, see hydroxide, OH. All hydroxides are insoluble. But if it is sodium or potassium hydroxide or ammonium hydroxide, then it is soluble. Okay. Then NaCl, soluble or insoluble? How do we know? Because of sodium. Right. Any sodium salt is soluble. Plus NaCl, you know, we use in the kitchen. You put in water, what happens? It dissolves, right? So we know that. Next, aluminum hydroxide, soluble or insoluble? How do we know? Here, hydroxides. All hydroxides are insoluble, except if it was sodium, potassium, or ammonium hydroxide. You understand that? So you need to know which salts are soluble and insoluble for all these reactions. Okay? There's an easy way to learn, which I will teach you. Okay? Now, same way, we have the next example also here. FeSO4 plus NaOH gives Na2SO4 plus FeOH twice. So here, let's look at the table and see. Is FeSO4 soluble or insoluble? Ferrous sulfate or iron sulfate. It's a sulfate. All sulfates are soluble, and Fe is not in the exceptions. NaOH, soluble because of Na. And Na2SO4, soluble because of Na also, because of SO4 also. Both. Na is also soluble. All sulfates are also soluble. And then FeOH twice, insoluble. Why? OH. All hydroxides are insoluble. Okay. So you see, every reaction you'll need to know this. Okay. Anyway, what did you understand from this is base plus salt gives base plus salt gives base plus salt. Just that one of the base formed here should be insoluble. Okay, that's what we have seen over here. Just write the first reaction here. AlCl, that's the last. We will write that and we'll stop, and then we'll be doing maths. Write down the aluminum chloride plus sodium hydroxide. Okay, to continue with this chapter, we stopped last at preparation of acids and bases using different methods. Okay, first we saw acid can be prepared by direct combination, hydrogen plus a non-metal. Same way, bases also can be produced using direct combination, that is metals plus oxygen. Then we saw acidic oxides and basic oxides. Remember all this? Acidic, what are the acidic oxides? Carbon dioxide, sulfur dioxide, sulfur trioxide, phosphorus pentoxide. Why are they called acidic oxides? Because they join with water to form an acid. Okay. Then we saw from salts, that is salt plus acid forms salt plus acid. Remember the condition here? From a less volatile acid, you can produce a more volatile acid. We wrote down the list of acids from the least to the most volatile. Which was the least volatile acid?
Sulfuric.
Sulfuric. Next was
HCl.
HCl. Next,
HNO3.
nitric acid. And last,
Carbonic acid.
H2CO3, carbonic acid. Okay. So from a less volatile acid, you can make a more volatile acid. And that's how we saw how acids were produced from salt. Also, we saw that sulfuric acid is a dibasic acid, which means there are two hydrogen ions in it. And if we increase the temperature to more than 200 degrees Celsius, what's going to happen? Both the hydrogens will get displaced. And then you'll get a salt that you don't want, potassium sulfate or sodium sulfate. These salts are bad, they will spoil the apparatus. Right. So we need to keep the temperature less than 200 degrees Celsius. Then we get potassium bisulfate or sodium bisulfate. Okay, this is all what we saw in the last class. You're upset or what? You look confused. You're not sure? You remember all this? Okay. All right. Then for bases, here also we have salt plus base gives salt plus base. But the base that is being produced here should be a precipitate. That means it should be insoluble. So last class we went through all the soluble and insoluble salts, and we saw that aluminum hydroxide and iron hydroxide were insoluble. Do you remember that? I told you I will tell you how to remember it easily. Okay, so we'll go through that later on. Okay, the last one is acids by oxidation of non-metals. So acids need a non-metal in it, right? So here they're oxidizing the non-metal. So sulfur is oxidized using HNO3. So what you understand here is HNO3 is a strong oxidizing agent. It oxidizes sulfur, and sulfur becomes sulfuric acid. Okay. Yeah, this reaction is a little different. It doesn't follow the normal rules. So you have to just write this reaction and learn it. Okay. Sulfur plus nitric acid forms sulfuric acid plus water plus nitrogen dioxide. Remember the rule we just now said over here? From sulfuric acid, you can make nitric acid. That means from a less volatile acid, you can make more volatile acid. But see, here it's exactly the opposite. They're using nitric acid to make sulfuric acid. So how is this possible now? What is the rule? From a less volatile acid, you can make a more volatile acid. But here it's exactly the opposite. They're using the HNO3, the more volatile, to make the less volatile. So that rule works only when you mix it with a salt. Only salt plus acid form salt and acid will follow that rule that a less volatile acid can produce a more volatile acid. Here, are we mixing acid with salt? Huh? No, it is acid with sulfur, non-metal. Okay, so that rule doesn't apply over here. Okay, write on this reaction, everyone. Sulfur plus nitric acid forms sulfuric acid plus water plus nitrogen dioxide. Also, before you write, look at the basis side. Okay. By the way, acid. Which acid was produced here? Sulfuric acid. On this side, we are producing a base. The base here is lead oxide. How are we producing lead oxide? Is by decomposition of lead nitrate. So lead nitrate is a salt. How do you decompose it? Is by heating it. So when you heat it, it decomposes. Means it splits into lead oxide, nitrogen dioxide, and oxygen. Okay. All of you write down these two reactions. I'll just come in a minute. I have to write down these two reactions. Preparation of sulfuric acid and preparation of lead oxide. Okay, I'm just going to skip this next part, and then we're going to formation of acid rain. Okay, now what is acid rain? You know what's an acid rain? What is acid rain, everyone? Yeah, the first rain of the season, it doesn't rain water, it rains acid. Okay, yeah, so there are four acids that can come down. Okay, so first is acids by sulfur. Okay. So first you see that sulfur is released from anything from fossil fuels, petrol, diesel. When you burn any of these things, sulfur is present in that. Okay. This sulfur, when it burns, it joins with oxygen to form sulfur dioxide. Okay. Now this same sulfur dioxide can join, it's in the air, right? It can join with water to form H2SO3. That is sulfurous acid. Now some of this SO2 will further get oxidized to form SO3. Okay. And this SO3 also will join with water to form H2SO4. Okay, so you get two acids here with sulfur. One is H2SO3 and H2SO4. What is H2SO3? Sulfurous acid. And H2SO4 is sulfuric acid. Okay, same way, we're going to stop in 1 minute. Nitric acid is also formed. So that is from nitrogen. Now, where is nitrogen present? The air itself. Air has a lot of nitrogen. Okay, this nitrogen will join with oxygen only when there's extremely high temperatures, like a lightning or a spark. A spark is a lightning. You know, sparks. Where are sparks formed? Huh? Come on.
Automobile engines.
All vehicles. Vehicles have spark plugs. Okay, and they keep sending sparks to ignite the fuel. Okay, so lightnings are happening inside your vehicle every time it's running. So at that time, nitrogen will join with oxygen to form NO2. None of the reactions I'm writing are balanced. They have to be balanced. Okay. So this air is also filled with nitrogen dioxide. This nitrogen dioxide joins with H2O to form two acids, HNO2 and HNO3. In one step itself, you get two acids, that is nitrous acid and nitric acid. Okay, so totally four acids are released or produced in the first rain of the season. Okay, that's why never go out in the first rain. You know that, right? You might say, "Oh, first rain, let me go out and enjoy the rain because it's so nice," right? We have all done that, but I mean, it's not very severe. These acids are extremely dilute. Okay, so it's not like strong acid you'll get burnt or anything, but it can be a little harmful, especially for buildings. You know, it can reduce, destroy the paint or plants. Okay, their water might become acidic. It can destroy the plants. All right, write down these reactions and then we will end. Okay, so revision of acid rain. The air contains a lot of pollutants. Okay, pollutants made out of sulfur and nitrogen. Okay, now sulfur is present in fossil fuels. What are fossil fuels? Petrol, diesel, coal, CNG. All of these are fossil fuels. And when you burn fossil fuels, the sulfur in them, they combine with oxygen to form sulfur dioxide. So this is one of the pollutants that is present in the air, sulfur dioxide. Another pollutant is nitrogen. Nitrogen reacts with oxygen. You get nitrogen dioxide. Okay, so these are two very, very common pollutants present in the air, sulfur dioxide and nitrogen dioxide. How does sulfur join with oxygen is when you burn fossil fuels. How does nitrogen combine with oxygen? Both are present in the air, but when do they join? When do they combine?
Lightning.
Okay, lightning or a spark, extremely high temperatures, around 3000 degrees Celsius. Okay, so above 3000, 4000 degrees Celsius, that's the time they combine. Now you get this high temperatures only when there's a lightning, or even inside a car or a bike, there are lightnings inside. The sparks are lightnings. Okay, so that time these gases combine to form nitrogen dioxide. Okay, so now sulfur dioxide, let's see the first one, sulfur dioxide. Sulfur dioxide joins with the water when it rains, the first rain, that sulfur dioxide joins with that water to form the first acid, which is H2SO3. Okay, then some of the sulfur dioxide again gets oxidized to form sulfur trioxide. And then the sulfur trioxide joins with oxygen, joins with water again in the acid rain to form the second acid, which is H2SO4. Okay, so here itself there are two acids formed, sulfurous acid and sulfuric acid. Is this much clear, everyone? Now, the second pollutant, which is nitrogen dioxide. This nitrogen dioxide reacts with water, NO2 reacts with water, that is the rain in the acid rain, the rain, which combines with nitrogen dioxide to form two acids, HNO2 and HNO3. HNO2 is nitrous acid and HNO3 is nitric acid. So these what I've written in red are the four acids that are produced during an acid rain. Is this clear? Write it down, everyone. Okay, some uses of acids. Then tartaric acid is an acid that is used in or present in baking powder. Okay, acetic acid is very common. We call it vinegar. All right, we use it for cooking or in Chinese food. We put acetic acid. Right. Then hydrochloric acid is pickling of metals. Now, what is pickling of metal means? Removing the oxides present on metals. The metals, if you leave it outside, it gets a layer of oxides on it. Okay, like iron, if it gets oxides in front of it, on it, then that becomes rust. So to remove that rust or to remove any oxides from any metal, they can just wash it with hydrochloric acid. So the metal will again get cleaned, okay, and shiny, all those things. Okay, on this side you have bases. All right, so from these bases, which were the strong bases? The strong bases we saw in the beginning, there were only there were four bases that dissolved in water. From those four, two of them were strong, two of them were weak. So which were the strong bases? Calcium is the weak base. Strong base, there were two of them. You have written this down in your first page when we explain the first chapter, first class of this chapter. I explained to you that. Okay, so the two strong acids are the two strong bases are potassium hydroxide and sodium hydroxide. And the two weak bases or weak alkalis, calcium hydroxide and ammonium hydroxide. Okay, so here we can see three of them at least. Okay, so the strong one is sodium hydroxide. See, that is used in manufacturing of soap. By the way, what is the taste of acids and bases? How do acids taste? Salty? Sour, okay. And how do bases taste? Bitter, okay. Have you tasted soap? Good taste, okay. It is bitter in taste, okay. Then calcium hydroxide is uh, present in bleaching powder, washing clothes, okay. So that's one of the weak alkalis. Then magnesium hydroxide is an antacid, okay. You know Eno, okay. Same like there's another thing called milk of magnesia. So whenever you have acidity, you can drink that. So it works as an antacid. See, you're drinking a base. Okay, just a minute. Yeah, what I was saying is when you have acidity, okay, we have to take a base so that the acid and the base will combine and become what? That reaction is called neutralization reaction. Yeah, it forms salt and water. So what happens to the acid? What happens to the base? They both disappear, right? The acid is gone, the base is gone, and you get something salt and water, which is not harmful at all. It is not doesn't do any harm. Okay, so that is why we take an antacid when we have acidity. So the antacid that is used most commonly is magnesium hydroxide. Okay, MgOH twice. Next, in fire extinguishers, they use aluminum hydroxide. In softening water, calcium hydroxide. Okay, so we have learned about soft water, I think in 8th or 9th standard, hard water, soft water, and then we had calcium hydroxide um, to make it soft. Calcium hydroxide is also called as flakered lime or just the word lime. Okay, when we use the word lime, it doesn't mean the lime juice or lemon that we use in the fruit. That's not what it means. Okay, lime means calcium hydroxide or calcium oxide. They're called lime. Okay, and then you have ammonium hydroxide, which is used to remove grease stains from clothes. Okay, so some examples of acids and bases. All right, so now here is the reaction of an acid with a base, which you're already familiar with it. That is an acid plus base gives salt and water. Okay. During this reaction, there are some things that you observe. Yeah, so the hydrogen from the acid will join with the OH from the base. Those two join to form water. And the metal from the base joins with the non-metal from the acid to form the salt. Right. Write another example. Give me an example of an acid and a base. Tell me an acid. Aman, do you know any acid? Hydrochloric acid. That's used here. Anything else? No acid?
Acetic acid.
Yeah, use one of the strong acids. The three acids, no? Sulfuric acid or what's the third one? Nitric acid. Okay, let's take nitric acid as our example because there's only one hydrogen. What do we call this type of acid with one hydrogen? Mono
Acidic.
No, monobasic acid.
Monobasic acid.
All right, so monobasic acid. Let's react it with any base. Tell me a base. To keep it simple, again think of a monoacidic base.
Potassium hydroxide.
Something else.
Yes,
Okay.
potassium hydroxide.
Potassium hydroxide, KOH. Okay, so here the H joins with the OH and the K joins with the NO. Right. So what is the salt formed over here? See, the salt and water. Potassium nitrate. KNO3 is potassium nitrate, that is the salt, and the blue color is the water, H2O. Right. This is the neutralization reaction. Right, everyone? Right, heading is neutralization reaction and write this example. Okay, done, everyone? Okay, the next topic, indicators. Okay, so what do you think an indicator is? Anyone, quickly. You're thinking about bike. Tell me, what is indicators here in chemistry?
pH level.
Okay, it calculates the pH of any compound or element and it tells you whether they're acid or whether it's a base. Okay, so it's just an pH scale is a scale showing the concentration of hydrogen ions present in that substance. Okay. Now, if there's more hydrogen ions, that means it's more acidic. It's an acid. If there's less hydrogen ions, then it's a base. Okay. So it's just a measurement of the amount of hydrogen ions present in it. And this is how. Let's see the definition for pH. Where is that? Yeah, here. pH is defined as the negative logarithm to the base 10 of the hydrogen ion concentration expressed in moles per liter. Okay, so it is some negative thing. So, for example, if I say the pH is 5, it means it is 10 raised to minus 5. Okay, that's the concentration of the hydrogen ions present in it. If I say pH is 11, that means it is 10 raised to minus 11. That is the concentration of hydrogen ions. So in which one there is more hydrogen ions? 10 raised to minus 5 or 10 raised to minus 11? Minus 5 is bigger, right? So 10 raised to minus 5 means there is more concentration of hydrogen ions. Okay, so we don't say 10 raised to minus 5, we just call it 5. Okay, so if the pH is 5, there is more hydrogen ions than if the pH is 11. Basically, the smaller this number, the more acidic it is, and the bigger that number, the more basic it is. So if the pH is 7, that is neutral. 7 is neutral. Anything less than 7 gets more acidic the farther you go away from 7. And if you go away from 7 to the right side, it becomes more basic. Okay, so 7 is neutral, 6 is slightly acidic, 5 is more acidic, 4 is more and more, and 1 would be the most acidic. Okay, it goes maximum till 0. Now on the other side, 8 is slightly basic, 9 is more basic, and 14 will be the most basic, strongest base, 14. Okay, so now to calculate the pH, you have indicators. Okay, there are two types of indicators that are there. One is the common acid-base indicator, and the other is the universal indicator. A common acid-base indicator will change color based on whether it's an acid or a base. Okay, it just has two colors, one color for acid and one color for base. You can only tell whether it's an acid or a base. That's all. A universal indicator will give you the different colors for different pH values. What's the difference? Tell me. What does a common acid-base indicator do?
Indicates if it's either acid or base.
Yeah, just you can tell whether it's an acid or a base. There are only two colors. This color means acid, other color means base. What about universal indicator?
Different colors for different.
Daryl was not listening, I was noticing. Okay, you have different colors for different pH values. Okay, so in your book, you might have a color page of it, and mine it's black and white image, but they're given the colors over here. Okay, for example, if the pH is red, what does it mean? If the indicator turns red, it means the pH is 1, around 1. If the indicator turns orange, then we know the pH is around 3. Yellow is around 5. Green is 7. Blue is around 9. Indigo is around 11. And violet is around 14. If you notice, these are actually the rainbow colors. Right. Okay. So if you test something and the color comes red, what do you understand from that? So what is it, acidic or basic or what?
Acidic.
Highly acidic, right? Because red is like very strong acid. If the pH comes blue, then if the color is blue, then you know it's a
Base.
not very strong base, a weak base. Okay, so it tells you the strength of the acid or the base also. Okay, this the universal indicator. 7 is neutral. So water is neutral. Okay, it's not acid, it's not base. Salts are neutral, not acidic, not base. Okay. All right. Now let's look at the common acid-base indicators. You have three indicators. Okay, the first one is called litmus. You've heard of litmus paper? Yeah. The second one is methyl orange, and the third one is phenolphthalein. These are the three indicators. Okay. So here you can see the color change, what color it becomes. Okay. So litmus solution turns red if the pH is anywhere between 0 and 5. And litmus turns blue if the pH is between 7 to 14. So mostly we use this. Okay. If the color is red, then you know it's an acid. If it's blue, then you know it's a base. Okay. Then you have methyl orange. Methyl orange is actually orange in color. If you put it in a pH between 0 to around 3, then the color of methyl orange turns pink. So it's an acid. Okay. And if it's yellow in color, then it's a base. But you can see, no, like if it's 5 also, it shows yellow. Okay. So you might think, okay, it's a base, but 5 is actually what? The pH is 5, then it's actually an acid. Okay. So this is more towards the left. So it's not a very good indicator, but at least you can tell that methyl orange, if it turns pink, that means what type of an acid is it? It's a strong acid. That's why it turns turn pink. The pH has to be between 0 and around 3. So that means it's a very strong acid. And then you have phenolphthalein, which is generally colorless. Okay, if you put in acid, it will remain colorless. And if you put it in a base, it will turn pink. Okay, so these colors you have to learn. So once again, litmus paper, normally it is around purple in color, or you can get blue litmus paper, you can get red litmus paper also. But when you put litmus paper in acid, what color does it turn?
Red.
Red. And if you put it in base, blue. Methyl orange is generally orange.
If we get blue litmus paper and if we put in
Base, it will remain blue. Okay. Yeah, methyl orange is generally orange, and if you put in acid, it turns methyl orange turns pink, and if you put in a base, it turns yellow. Neutral is like methyl orange. Orange is neutral. And phenolphthalein is generally colorless. When you buy it, it's colorless. If you put in an acid, then it remains colorless. Put in a base, it turns pink. Where are you all? Anna, Sneha, Gloria, Ryan. Ryan, what's happening, Ryan and Gloria? You need me to call you in between, or any doubt, anyone? In indicators? Okay, here there's a table of all the colors. Okay, litmus is in neutral. Neutral litmus is purple. Acidic is red. Alkaline is blue. Methyl orange. Neutral is orange. Acidic is pink. Alkaline is yellow. Phenolphthalein, you get both. You get colorless phenolphthalein and pink phenolphthalein. So colorless will remain colorless in acid and pink in alkaline. If you buy pink phenolphthalein, then it becomes colorless in acidic and pink in alkaline. Same colors. Okay. All right. Yeah, here are some pH values of certain substances. Okay, looking at this, you can tell which is the strong acid and which is a weak acid, or which is a strong base and which is a weak base. So from all these acids here, which is the strongest acid?
Sulfuric and hydrochloric acid.
They both have pH around 1, right? And see, weak acid is lactic acid. Milk has lactic acid, which is a weak acid. All right, and then on the alkaline section, which is a strong alkali.
Human blood.
Strong is away from 7. So sodium
Sodium
hydroxide.
hydroxide.
Yeah, that's the strongest alkali. The weak alkali here is human blood. This is very close to neutral. Neutral is 7, and blood is around 7.3. Now the blood can range from 6 to 8. Okay, your blood can become alkaline, it can become acidic, both. Okay, so naturally it's supposed to be alkaline, 7.3. That is good. But if you eat a lot of protein, especially animal protein, then your blood will become more acidic. Okay, and if the blood is more acidic, there is more chances for bacteria to grow in your blood. Okay, but if you eat more vegetarian food, then your blood will be more alkaline. Okay, and then you'll have more immunity, less chances for bacteria to attack you. Okay, so keep that in mind about the blood's pH value. It changes based on what you eat. Whatever you eat becomes your blood, right? Everything gets digested and it turns into your blood.
What about when you drink water?
That also becomes blood. Yeah, and then when there's too much water in the blood, you have to pee it out. Your kidney removes that water, right? So everything that goes into your stomach becomes your blood, whether it is liquid or solids.
Now, if by mistake this follows model,
So if it cannot get absorbed in the intestines, then it will pass out like that itself. Okay. So anything that is absorbable gets digested in the intestine. If it's not digestible, then it just passes out. Sometimes it can get stuck in the way. So that is also there. Okay, next we're going to salts. So we have already seen this exact same reaction before this. Okay, that is sodium hydroxide plus H2SO4, H2, dibasic acid. And what we saw is when a dibasic acid reacts, it dissociates in how many steps? 2 steps. In the first step, only one hydrogen gets replaced. In the second step, the second hydrogen gets replaced. Okay, so here you have the first step and the second step. In the first step, there's only partial replacement. So out of the 2 hydrogens present here, only one of it is replaced with sodium. So you get NaHSO4. And then if both the hydrogens are replaced, you get two sodiums, Na2SO4. Now this reaction we saw in the preparation of HCl and HNO3. Okay, here. Similar reaction. Preparation of HNO3 and preparation of HCl. Okay, so in both the cases, we kept the temperature less than 200 degrees Celsius so that there would be partial or complete. We kept the temperature less than 200 degrees Celsius so that there would be partial replacement. Okay, out of the 2 hydrogens, we only want one of the hydrogens to get replaced. We saw some advantages for that. If both the hydrogens are replaced, then here what salt you'll get? From H2SO4, if both the hydrogens are replaced with 2 potassiums, then you'll get K2SO4. And here also, if 2 hydrogens are replaced with sodium, you'll get Na2SO4. Come on, we spent half an hour on this topic. We don't study this, what happens. You don't know what I'm talking about. So what are the disadvantages of having that salt, K2SO4 and Na2SO4? Yeah, it sticks to the apparatus. Okay, in the production of HNO3 and HCl, those salts just spoil the whole reaction. Okay, they stick to the apparatus and destroys the apparatus. Also, there are other factors which are not necessary. That is, if you put high temperatures, the fuel is wasted, glass might break because of that high temperature. But the main thing is the salt that is formed is it destroys the apparatus. Okay, so we keep the temperature less than 200 degrees Celsius so that we have partial replacement. Partial replacement. Okay, anyway, what is a salt that is produced when there's a partial replacement? What is a salt that is produced? See, this is acid plus base gives salt and water. So what is a salt that is formed on partial replacement in this reaction? NaHSO4. And if there's complete replacement, you get Na2SO4. What is this NaHSO4? What is the name of this?
Sodium.
Sodium bisulfate.
Sodium bisulfate. And what is Na2SO4? Sodium sulfate. Okay. Now from this, sodium sulfate is a normal salt. Normal salt means it only has a positive part and a negative part. Positive radical and negative radical. Okay. Let me write it down over here. Normal salt. A normal salt has only two parts. Okay. That is the positive radical and the negative radical. So in this example here, Na2 is the positive radical, sodium, and the negative radical is SO4. Okay, this is the normal salt. But in the partial replacement, you get a different type of salt. What salt is that? What do you call that salt?
Rejoin the meeting.
कल छुट्टी है तो बच्चे आ रहे तुम्हारे पास
Ahmed,
हम हमारा सिर्फ हम
I'm trying to understand what he's saying. Which answer is there? What salt is that?
Sir,
Okay.
rejoin the meeting.
हाँ
Teacher, and you're talking some nonsense over there, and the class is going on.
मैं तो क्या
Okay, what type of a salt is that? NaHSO4. Is this a normal salt? What do you call this salt? See, it has Na, which is the positive radical. It has SO4, which is the negative radical.
Sodium bi-
And in between that, you have this hydrogen. This hydrogen, because of this hydrogen, this is not a normal salt. This is an what? Acid salt. Okay, it's called an acid salt because of the presence of the hydrogen ion. Is that clear, everyone? Rejoin. Okay, so they have given so much more explanation about acid salt and normal salt. Okay, so I'll just read it from here. Let's read normal salt first. Normal salt, how is it formed? By complete replacement of the replaceable hydrogen ions of an acid molecule by a basic radical, means by the positive ion, by the Na. That's the basic radical. How is acid salt formed? By partial replacement of that replaceable hydrogen ions of that acid. By what? By the basic radical. That is the Na. So how do you make a normal salt? How do you make an acid salt? So when you make an acid salt, you have to go slow. Like if you're giving temperature, give less temperature. Okay? Don't go full on. Like, if you're giving catalyst, don't put too much catalyst. Go slow. Then you'll have partial replacement. Here, preparation. If you want to prepare an acid salt, it is formed when the amount of base taken is insufficient for complete neutralization of the acid. Like if you're mixing acid and base, don't put full base inside that acid. Put base drop by drop. So you're not giving so much of base so that complete replacement can take place. You're letting it happen partially by giving a little bit of base. Yeah. Either give a little bit of base you have to give slowly. Okay. But when you're preparing a normal salt, then you will give sufficient amount of base so that complete replacement takes place. See, here are some examples of acid salts that are produced from acids. Now HNO3, HCl, and CH3COH, they only have one hydrogen that can be replaced. So these three acids cannot produce acid salts. Right? If the hydrogen is removed from here, then no hydrogen is there at all. So you don't get an acid salt. But look at these four examples here. H2CO3, H2SO4, H2SO4, and H3PO4. The first three of them, they have two hydrogens, and the last one has three hydrogens. So you can get acid salts. Now from H2CO3, if you take out one hydrogen and put a sodium over there, you'll get what? NaHCO3. From H2SO3 also do the same thing. Take out one hydrogen and put sodium over there. You'll get NaHSO3. Here you'll get NaHSO4. And here you'll get Na. Okay. So here you can get two acid salts. You can remove one hydrogen. You can also remove two hydrogens and you'll get acid salt. If you remove all three hydrogens, then you'll get a normal salt. We saw all these reactions before this, right? So if you remove one hydrogen, what will you get? What's the name of that salt? If you remove one hydrogen from here and put one sodium there, one hydrogen you're removing, so two hydrogens are remaining. NaH2PO4. Okay, then you remove the second hydrogen also and put two sodiums now. Na2HPO4. So these are the two acid salts. If you remove the third hydrogen and put one more sodium, what will you get? Na3PO4. That is a normal salt. Okay. Is that clear, everybody? All the different type of salts that you can get?
Yes.
Oh yeah, same thing was given here. Okay, so they have mentioned the acid salt on the left and the normal salt on the right. Okay. Then you have many more different type of salts like basic salt and double salt and mixed salt and complex salt. But I don't know if they're very important. Show me your textbook. Let me see if it's there. Yeah, it's not there for you. I'll just explain in very short. Now, just like an acid salt. Now, what is an acid salt, everyone? Like if you look at a salt, how do you know it's an acid salt? Yeah, there will be hydrogen in the middle, right? In between the positive and negative radical, you will have hydrogen. In the same way, a basic salt, you see what's there in between? Yeah.
Base.
Base means hydroxide, right? Hydronium H plus. Hydronium. Yeah. Hydroxyl or hydroxide. OH is hydroxyl ion, or we call it hydroxide. Okay, so there's a OH in between, then that becomes a basic salt. Next is a double salt. Double salt is just two salts that are joined together by water of crystallization. Okay, for example, alum. Alum is a combination of two salts, K2SO4 and Al2SO4 thrice. And they are joined by this 24 water molecules. So it forms a crystal-like structure. Okay, this water here is called water of crystallization. Right. Okay, so there are two salts for alum. You know where alum is used? You can buy alum from any medical shop or anything. Alum is used to put in water if there is a lot of impurities in water. And this alum will dissolve with the water and it will stick to the particles and make the particles heavier. And so these particles will settle down. And so you get clean water. Okay. So if you have muddy water and you want to make it clear, just put alum in that. The muddy water will the mud will settle very fast and you'll get clean water. Okay. That is where alum is used. Okay.
But will it be clean enough to drink?
Yeah, I mean, no, the bacteria won't get destroyed, but the dirt will settle down. Okay. Whatever does not sediment easily will sediment fast. That's the only thing alum does. Okay. So what's a double salt is? Two salts that are combined using water of crystallization. Okay. And to make water of crystallization, you need like saturated solution. Take a saturated salt, heat it, make it super saturated, and then you cool the super saturated solution, you will get water of crystallization. Like, okay. All right. Then mixed salt. Mixed salt is again not very important at all, but it is like it will have two positive radicals and one negative radical, or one positive radical and two negative radicals. So look at this, NaKCO3. So Na is a positive radical, K is a positive radical, right? Both are metals. And CO3 is a negative radical. CO3 is a radical together. Right? Then CaOClCl. So here Ca is a positive radical, OCl is a negative radical, and this chloride is another negative radical. So you'll have either one positive and two negative radicals, or two positives and one negative radical. Okay, again, not important. And then you have you have complex salts. Complex salts are, there are a few of them. You use them in some reactions, like this Nestler's reagent. That is important when you study the last chapter in chemistry. Okay, that time we'll be seeing that. Yeah, we don't need to go through the rest of it. I think even this is important. Sodium silver cyanide. This comes in electrolysis chapter. So all of whatever you're studying in this chapter comes later on in some other chapter in this book. Yeah. Okay. We'll go to the next important, the most important topic, which we saw before again, is the soluble salts and the insoluble salts. Okay. So what are the soluble salts? Now a salt has two parts. What are the two parts of a salt? Salt has a positive radical and a negative radical. Okay. Now most of the time the solubility is depending on the negative radical. Okay. Just in the first point here, the solubility of the salt is based on the positive radical. So what is mentioned here is, if the salt contains sodium, potassium, or ammonium as a positive radical, then that salt is soluble. Okay, no matter whatever is there in the negative. If the positive has sodium, potassium, or ammonium, it is soluble. Okay. From point number 2 till point number 11, we're all talking only about the negative radical. So all nitrates and nitrites are soluble. All bicarbonates are soluble. All sulfates are soluble. All chlorides are soluble in general. Everything else is insoluble. Okay. Now, how will you memorize this? So there's an easy way to memorize it. Okay. You just think of the three strongest acids. What are the three strongest acids? HCl, H2SO4, and HNO3. Okay. The acids have nothing to do with this. Just an easy way to remember it. Okay. So in the acids, look at the negative radicals. See, you have chloride, sulfate, and nitrate. They are all soluble. You see chlorides, sulfates, see sulfates, and see nitrates. Nitrates are here. Okay. So these three of them are soluble. Plus, there are more. Along with the nitrates, also remember that there are nitrites. Okay, so nitrites means NO2s. Something with NO2 is a nitrite. And also you have bicarbonates. Bicarbonate means something with a HCO3. This is a bicarbonate. Yeah? Gloria also? Gloria, I just put the people in whose camera are off in waiting room. You also want to go there? Okay. All right. So, yeah, easy way to remember this, right? So, which are all the soluble salts? Think of these three first. What is that? Chlorides, sulfates, nitrates. And then the other than that is nitrites and bicarbonates. Okay. Yes, there are exceptions for everything. Like for nitrates and nitrates, there is no exception. That means all the nitrates and nitrites are soluble. Whether it is potassium nitrate or calcium nitrate or sodium nitrate or aluminum nitrate or tell any nitrate, they are soluble. Bicarbonates also, there are exceptions, weird exceptions. That is the potassium bicarbonate and sodium bicarbonate. See what we said in the beginning, potassium and sodium salts are all soluble. But potassium and sodium salts of the bicarbonates are sparingly soluble. Sparingly means Yeah, maybe if you heat the water or if you mix it nicely, then little bit will get dissolved. Okay. Then sulfates, all sulfates, but there are few exceptions, four exceptions. Pb, that is lead sulfate, silver sulfate, and calcium sulfate, and barium sulfate. These four sulfates are insoluble. And chlorides, again, there are three exceptions: lead chloride, silver chloride, and mercury chloride. These are insoluble. But they're soluble in, PbCl2 is soluble in hot water. Okay, so there's a lot to memorize. You have to spend at least 10 minutes and just learn this, you will get this. And then all these other ones are insoluble, like sulfite. What is the formula for sulfite? Tell me, sulfite. Sulfite is SO3. SO4 and SO3. Then sulfides. Sulfide is what? Only S. Carbonate is CO3. Oxides is O. Could be O2, O3, depend on the valency when you crisscross. And then hydroxide is OH. And phosphate is PO4. PO4 or PO3? Phosphate is PO4. Okay. So you can just make a list of these soluble and insoluble and learn them. I'll just come in a minute or two. Yeah. So after this, you're studying different methods to prepare salt. So there are different methods to prepare soluble salts and different methods to prepare insoluble salts. So that's why you need to know which salt is soluble and which salt is insoluble, so that you know which method to use to prepare them. Okay. So here in this book, they have just categorized into 5 different groups. Okay. See, the headings are here: neutralization, then neutralization with titration. Titration is where you add one of the components drop by drop. Then displacement, direct combination, and double decomposition. Okay, that's it. 5 different type of reactions that are used to prepare salts. So for each one, you'll see there's a different, they have written insoluble, soluble, everything, all the bases and the salts have been mentioned separately as soluble or insoluble. Okay. So like if you see it for soluble salts, to prepare soluble salts, which method will be used? First, second, or third, or even the fourth. Fourth method can be used for both soluble and insoluble salts. And the fifth method, which is double decomposition, is used only to prepare insoluble salts. Okay, so that's how they have categorized it. Okay, so in your book, so they've given the 3 methods. So for direct combination, they have mentioned for insoluble salts. Then oxides, calcium oxide, acetic oxide plus basic oxide forms a salt. And then the last one, double decomposition is also mentioned. Okay, now they are only, they're explaining 7 salts. There are 7 salts here. Okay, so let's just note down what are these 7 salts. The first salt is iron chloride. Okay, FeCl3. The next one is zinc sulfate and iron sulfate. That is Zn, ZnSO4 and iron 2 sulfate. That is FeSO4. The same methods for them. We'll just note down these salts that we're going to study. Third one is lead chloride, PbCl2 and calcium carbonate. You can just follow from your book. We'll write down after this. Fourth one is preparation of an acid salt, sodium bicarbonate, NaHCO3. For all of these, you just have to learn the reactions, okay? That's all, for all these 7 groups. Fifth one is the neutralization reaction. That is any salt that is made using a neutralization reaction. Sixth one is copper sulfate, CuSO4. The last one is sodium sulfate crystals. Sodium sulfate is Na2SO4, but crystals. Crystals means with that water of crystallization. So there is 10 H2Os. Okay, so you have preparation of these 7 salts in this book. Okay, so let's see the first one. We'll do at least 2. FeCl3. FeCl3 is the most simplest reaction. They're using this method called direct combination. So before that, you should know whether FeCl3 is soluble or insoluble. Is it soluble or insoluble? Why? Chloride. All chlorides are soluble? No, there are some exceptions, right? But Fe is not an exception in that, right? So here, all chlorides are soluble except these 3. So Fe is not in that. Okay. So FeCl3 is soluble. So FeCl3 is produced by direct combination. The direct combination means Fe plus Cl, right? Formula for iron is Fe, formula for Cl is Cl2. So Fe plus Cl2 will form what? FeCl3. Valencies are there, that's why FeCl3. Okay, so and then you balance the equation. So Cl2 and Cl3 to balance, you'll make it 6. So here you add a 3, here you'll add a 2. So chlorine gets balanced. Then to balance Fe, put a 2 over here. Write on this first one, just write on first one with the reaction to prepare it. Okay, you got the first one? What method are we using? Direct combination. Then for zinc sulfate, we're using simple displacement. Okay, simple displacement reaction. Do you remember simple displacement reaction? You'll take a metal with a, like I explained, no? Huh? Active metal will replace the lesser reactive metals. Okay, so in this reaction, you're taking zinc with sulfuric acid. To prepare zinc sulfate, what are we taking? Zinc with sulfuric acid. Okay, now the condition for this reaction to take place is zinc needs to be more reactive than hydrogen. Is zinc more reactive than hydrogen? So there's an activity series. Do you have it? Zinc, I don't think zinc is more reactive than hydrogen. Okay, and we'll confirm with that. We'll confirm that later on. But anyway, so what happens here? Zinc replaces the hydrogen, so you get zinc sulfate, and who's remaining alone is hydrogen as a gas. Same thing happens even for iron sulfate. Okay, so you're taking iron with sulfuric acid. So here the iron replaces the hydrogen, and you get FeSO4 plus H2. Okay, but and if you want to convert them into something called like zinc sulfate, if you mix it with water of crystallization, that is, you make a hot supersaturated solution and cool it, you will get something called white vitriol. White vitriol is zinc sulfate with that water of crystallization. Here you can see the reaction in your book. ZnSO4 dot 7H2O. And same way, FeSO4 also, if you mix it, do the same thing with water, that is, make a hot supersaturated solution and cool it, you will get FeSO4 with 7H2O, and that is called green vitriol. Okay, so zinc sulfate is white vitriol, and ferrous sulfate is, or iron sulfate is green vitriol. Okay, okay, just write down this much also, and then we'll end after that. Yeah, so what was the method of preparation? Again, back to the first one. First one is FeCl3. Okay, so look at the procedure. See, the diagram is over there. Okay, look on the. Okay, I'll read it. Powdered iron is taken in a combustion tube. Dry chlorine gas obtained by passing the gas through concentrated sulfuric acid is passed through the combustion tube. The air inside the apparatus is expelled. See, the thing is we're drying the chlorine. Chlorine can be moist. There can be moisture in the chlorine. And so to remove the moisture from the chlorine, what they're doing, they're passing the chlorine through concentrated sulfuric acid. Concentrated sulfuric acid is known as a drying agent. Okay. So you can see in the diagram over here, chlorine is passed inside and dry chlorine comes out. So what did the sulfuric acid do? It dried the chlorine. It removed the moisture. Okay. All right. So that's all. What is the use? Again, I'm asking, what is the purpose of sulfuric acid in this experiment? Drying agent. What type of sulfuric acid should you use? Concentrated. Concentrated means sulfuric acid without any water. So then it will absorb that water. If you take dilute sulfuric acid, it has so much water already, it won't absorb more water. Okay, so you have to take concentrated sulfuric acid. All right, then you're passing the dry HCl through a tube. What is a tube called? The tube is called the combustion tube. Okay, so combustion tube is heating over there. Okay, heat is given from there. And what happens when you heat it? Where is the iron? Oh, there's iron wire. Okay, so that iron wire will join with the chlorine when there is heat and iron chloride is formed. Okay, now where is the iron chloride formed? In that, I'll just put this up. Okay, yeah, iron chloride is formed down at the bottom of that container, and they are using fused calcium chloride over there. That calcium chloride, what's the purpose of the calcium chloride? Calcium chloride used as a drying agent. Yeah, so that calcium chloride over there also is used as a drying agent. So to keep moisture out. Okay, so we have seen two drying agents used in this experiment. Okay, all of you read through that section. Laboratory preparation of iron-3 chloride. Okay, so just let's read this, continue to read this. So what happens over here? This iron, since you're heating it, it turns red hot. And this reaction is exothermic. Exothermic means it produces its own heat. So you don't need to further heat it. So you can stop that external heating now. So the reaction itself produces its own heat. Okay, the reaction is very simple. Iron plus chlorine forms iron chloride. We're using dry chlorine. How do we keep the chlorine dry? By using concentrated sulfuric acid as a drying agent. Now, iron chloride is highly deliquescent. You know what's the meaning of deliquescent? It absorbs moisture and it dissolves. It dissolves in the moisture, okay? So to keep it dry, what do? You have to use calcium chloride, that fused calcium chloride. Yeah, take it out. So that calcium chloride keeps it dry. Because if it was not dry, the iron chloride will just absorb moisture and dissolve in it. Okay. Note, anhydrous FeCl3. Anhydrous means FeCl3 without water. Anhydrous FeCl3 cannot be prepared by simply heating hydrated ferric chloride. See, you can't take this hydrated ferric chloride and heat it. Normally you can, because if you heat it, the water will evaporate. Okay, but in this case, you cannot just take hydrated iron chloride and heat it, because what happens on heating? FeCl3.6H2O produces Fe2O3, iron oxide, that is rust, water, and HCl. So it forms a different reaction only. So you can't just remove the water from hydrated iron chloride. Okay. Anhydrous iron chloride, okay, there are uses. It is used as a catalyst in certain reactions. Intentionally, we don't use it anywhere as a catalyst. Not as far as I remember, nothing is used. Okay. All right. So that's about it. Any doubt in FeCl3 production? No. Next is zinc sulfate and iron sulfate. Okay. So the reactions are very similar over here. You're taking the metal and putting it in sulfuric acid. Okay. So let us look at that reaction. Step 1, take dilute sulfuric acid, 1 volume. 1 volume of acid and 5 volumes of water. Okay, that's the ratio. 1:5, which means it's dilute. 1 part of sulfuric acid and 5 parts of water in a beaker. Heat it on a wire gauze. Add some granulated zinc pieces a little at a time. Granulated means powdered zinc. Okay, so you're mixing sulfuric acid with zinc. Effervescence takes place. What is effervescence? Effervescence means bubbles are formed. Okay, what is this bubbles? Bubbles of what? Bubbles means some gas should be produced. So which gas is produced? Hydrogen. Okay, so when hydrogen is formed, you will see bubbles being formed. Add zinc till the metal settles at the base of the beaker. Okay, so keep adding zinc. Now, as you're adding zinc, that zinc is reacting with that sulfuric acid. Once all the sulfuric acid has reacted, then there's no sulfuric acid remaining because all the sulfuric acid has turned into zinc sulfide. Zinc sulfate. Okay, so that's why you will notice that the zinc is staying on top, bubbling, and some reaction is taking place. But once the bubbling stops and that zinc is settling down to the bottom, it means all the sulfuric acid has converted into zinc sulfate. The excess of zinc is filtered off. Okay, so once that zinc is settled down, then you filter out the zinc because there's not supposed to be any zinc remaining in the products. It's supposed to all have converted into zinc sulfate. Then collect the solution in a china dish. Use a filter paper. Okay, wash them and dry them in between with folds of filter paper. Okay, so quite simple reaction. Just keep adding zinc little by little till all the zinc is mixed up. Reacted with the sulfuric acid. Same thing for iron also you have to do. Oh yeah, and these two salts that are formed, you will not get anhydrous. You will get hydrated. That means they will join with the water. So there's a lot of water here along with the sulfuric acid, right? So it joins with the water and it forms hydrated. You'll get these salts, spiky, pokey salts. See, needle-shaped crystals are formed. So zinc sulfate forms ZnSO4.7H2O, which is called white vitriol. So here, zinc sulfate joins with water to form zinc sulfate.7H2O, which is white vitriol. The same way, FeSO4 also joins with water to form green vitriol. Okay. Filter the hot solution formed and allow the filtrate to evaporate at room temperature. Yeah, so you have to allow it to evaporate. Once all the water is evaporated, that's the time you get these salt structures. All right, so that's done. Okay, we'll go to the next one. The third one. What's the third? PbCl2 and PaCO3, lead chloride and calcium carbonate. So the method of preparation is double decomposition. Okay. See, in double decomposition also there are different types.
How do we like lead chloride or lead chloride?
Lead.
Okay.
Double decomposition has many different types. What are the different types of double decomposition reaction? Double decomposition has 4 types. Okay, first one is neutralization. Neutralization is where you have acid plus base gives salt and water. This is neutralization. Then acid plus salt gives acid plus salt. But the acid formed here will be more volatile. That was the condition for acid plus salt. We saw this previously. Same way you have base plus salt. Base plus salt also will form base plus salt. Here there are 2 types of reactions that can take place. One is the base that is formed here should be more volatile. Another one is the base should be a precipitate. If it's a precipitate, then that's called a precipitation reaction. Another last reaction is salt plus salt, which forms salt plus salt. Here also, one of the products that is formed, that salt should be a precipitate. Okay, so whenever precipitates are formed, we call that a precipitation reaction. So that's why they're given here double decomposition as precipitation. Means it is one of these two, the third or the fourth. Okay, so let's look at the reaction. Oh, it could be anything. It could even be the second reaction, but the salt should form a precipitate. See, look at the reaction. Lead nitrate plus HCl forms lead chloride. See, our aim is to produce this lead chloride. And the arrow is given down. What does that mean? It's a precipitate. Okay. And also, which type of reaction is this? 1, 2, 3, or 4? Huh? This is salt plus acid. So second reaction. Okay. Forms salt plus acid. The salt is a precipitate and the acid is more volatile. You see, HNO3 is more volatile than HCl. Remember this? Least volatile was H2SO4. Then is HCl. Then is HNO3. And the most volatile was H2CO3. Right? All of you remember all these things, right? We have done all this previously. Everything that we have learned will be used throughout. Okay? All right. So this is one reaction. The second reaction to prepare PbCl2 is, come on, tell me, what type of a double decomposition reaction is this? Salt plus salt. You see, it's PbNO3, that's a salt, plus NaCl, that's a salt. How do you know it's a salt? Aman is like trying to figure out, how is it a salt? How do we know? How do we know it's a salt? But how do you know? What is the rule for a salt? Metal and non-metal. The metal should not be hydrogen, and the non-metal should not be OH. That's the only rule. Any metal you can take, and any non-metal. If on the metal side, if you have hydrogen, then what is that? When I say metal and metal and non-metal means positive and negative. In the positive, if you have metal, and in the negative, if you have non-metal, then it's a salt. If on the positive you have hydrogen, and on the negative you have non-metal, then what is that? Huh? Acid. This is maybe the fifth time we're doing this, right? If you have metal on the positive and OH on the non-metal, that's a base. And if you have hydrogen here and OH here, Aman, what is it then? It's water. H2O. H2O. Okay, so positive will either be metal or hydrogen. Negative will be non-metal or OH. Clear? All right. So you can see how you think when you think of a reaction, okay, and you know you have to use a double decomposition reaction to produce PbCl. What do you have to think is you need something that has Pb and something that has Cl. To produce PbCl2, you need some compound which has Pb and another compound which has Cl. So the compound that has Pb is lead nitrate, and the compound which has Cl is either HCl or NaCl. We just need a Cl over there. It could be HCl or it could be NaCl. And here, what can we take? What are the other options? Pb, why NO3? Because that NO3 is producing the acid HNO3. And HNO3 should be more volatile than HCl. So we need an acid that is more volatile than HCl. So which are the acids more volatile than HCl? It's only two. HNO3 and H2CO3. So the other option over here is to use what? Instead of lead nitrate, what else can we use? Lead carbonate. If you use lead carbonate, then the acid that you produce here will be what? Carbonic acid. Okay. So these rules have to be followed, and then you can make a reaction in any order that you want. Are you all getting me, everyone? You got it? You got it? You got it. Aman? I know it's a little difficult. Tension chemistry is difficult. Okay. Uh, so tell me another way to do this reaction. So instead of lead nitrate, we can take lead carbonate, PbCO3. Now we don't know the valencies. Do you know the valencies? So from here you can see Pb's valency is 2, okay, and CO3's valency is carbonic acid, H2CO3. H2CO3. How the H2 came? Because CO3's valency is also 2. Okay, so PbCO3 is the formula. Plus, uh, you can take anything that has Cl. So tell me something other than this which has Cl. Something with a Cl. You can either put hydrogen or any reactive metal. Which reactive metal you can take?
Magnesium.
Magnesium chloride, MgCl2. Okay. So the Pb will join with the Cl and get what we need. Our aim is to get this PbCl2. And the Mg will join with CO3 to form MgCO3. Okay, this will form as a precipitate. You see, you can do this reaction anyhow. Just follow the rules and write a reaction. Okay. All right, so what happens here? The solution of lead nitrate and sodium chloride is then filtered. Where is that? We missed the starting. Okay, it is prepared by either adding dilute hydrochloric acid or sodium chloride solution to a solution of lead nitrate. So very simple, you're just mixing both of them. Yeah. Then the solution of lead nitrate and sodium chloride is then filtered. The heavy white precipitate of lead chloride accumulates as residue on the filter paper. It is then washed repeatedly with cold water. The precipitate is taken in a china dish with some water and is heated till the precipitate of lead chloride dissolves. Okay. Yeah. So what? Listen, you're just putting both together, whatever the two reactants are, putting both together, and you're not even heating it. Are we heating it? No, no heating also. Let the reaction take place, and you will get the precipitate form. Okay, so the precipitate is formed at the bottom. So to get the precipitate out, how? You use a filter paper, filter it out, you'll get the precipitate. Now that precipitate, you have to make it hydrated. How do you make it hydrated? Add some water, heat it in the water. Keep mixing it. Okay, still everything dissolves. Once everything is dissolved, keep heating it, and when you heat, the water will evaporate, and then remaining you will get the crystals. Okay, crystals of lead chloride. The second element here, second compound here was calcium carbonate. For calcium carbonate also, look at it. So it is salt plus salt. So you need one salt that contains calcium and one salt that contains carbonate. Okay. So the salt that contains calcium, we're taking calcium chloride. Chloride is very common, put chloride. And a salt which contains carbonate, take sodium. See, sodium and chlorine, very common. If you need a negative radical, use chlorine. If you need a positive radical, use sodium. Default. Okay, so it's a very simple reaction. Now the calcium carbonate that you get here is amorphous powder. Amorphous means anhydrous. Anhydrous, amorphous, they all mean the same thing. Okay. Dry. Dry means amorphous or anhydrous. Dry means without water of crystallization. And if there is water of crystallization, what do we call it? Okay, if there's water, then we call it hydrated or any other word is there for it? Huh? Or we'll just say water of crystallization. Okay. that water crystallization makes that salt into crystals. Okay. All right, so this is amorphous powder. You get an amorphous powder of calcium carbonate. What is calcium carbonate? Huh? Chalk. Chalk is calcium carbonate. Now, if you put water in chalk, does the chalk dissolve in the water? Huh? Yeah, it floats, but it does not dissolve. Right. So calcium carbonate is also like a drying agent. It absorbs moisture but does not dissolve in it. That is the property you need uh, for drying agents. Drying agents are supposed to absorb moisture and not get dissolved in it. Okay. Write down the reactions for this now. Okay. We have finished first and second. For third one, lead chloride. And for calcium carbonate, write down the reactions. Okay, we'll move on. You done? Aman, yesterday you didn't write? Okay, so this is the third one, right? Okay, what's next? Sodium bicarbonate. H is hydrogen carbonate. Short form for hydrogen is bi. Sodium bicarbonate. Okay. So how do we prepare this? First, we will take Na2CO3. What is Na2CO3? Sodium carbonate. It's a white color powder. Okay. Take that powder, put it in water, make a solution out of it. Okay. So you'll get this solution of sodium carbonate. Now keep it inside ice where it is cold. And then yeah, keep it cold. Then pass carbon dioxide gas through a tube right into that solution. Okay, when you pass carbon dioxide into the tube, the reaction takes place and you will get sodium bicarbonate. Sodium bicarbonate will precipitate at the bottom. Simple reaction. And say that once again. Take Na2CO3, mix it with water so that you get a solution of sodium carbonate. And then pass carbon dioxide gas through it and the reaction takes place. No heating, nothing. In fact, cooling. Right. And so you get this precipitate of sodium bicarbonate. Is the reaction clear? Easy one. Note, sodium hydrogen carbonate or bicarbonate is used in health salts. Health salts are the mixture of dry citric acid or tartaric acid and sodium hydrogen carbonate. On adding water, acid reacts with sodium bicarbonate to release CO2, which forms an effervescent drinks and releases gas pressure in the stomach. So what are we talking about here? What is this health salt? It's ENO. You know ENO? Have you ever put ENO in water? Yes. What happens? Bubbles are formed. That bubbles are carbon dioxide. Okay. So what is that ENO made up of? It's made up of dry citric acid or tartaric acid and the sodium bicarbonate. And when you mix it with water, an effervescence is formed. Effervescence is the formation of any gas. Which gas is formed? Huh? Carbon dioxide. Okay. And yeah, if you have any gas in the stomach, this removes that gas from the stomach. Okay, write down this reaction. All right, the next reaction is neutralization reaction. What is neutralization reaction, Aman? What is the reaction? Acid plus base gives salt and water. That's all you have to say. What is neutralization reaction? Yes, so take any acid. HCl, easiest acid, plus any base, easiest base, NaOH. Okay, so what is formed? Acid plus base gives salt and water. Which salt is formed? NaCl. Okay, so this is one method to form a salt. Neutralization reaction is the method to produce salts. Yeah, I mean nothing new over here. Just one thing new, there is that is heat of neutralization. Now these reactions, almost all neutralization reactions are exothermic. What do you mean by exothermic? Gives out heat. So the amount of heat given out in this reaction, if you take 1 gram of acid or a base, okay, that amount of heat produced is called heat of neutralization. What is heat of neutralization? The amount of heat produced when you take either 1 gram of acid or 1 gram of base. Okay, that heat produced is heat of neutralization. Okay, write down this example for neutralization. Make in your book, what's next salt? Number 6. Copper sulfate. Yeah. Copper sulfate is called blue vitriol. So we have so many vitriols. White vitriol was zinc, right? They've not written it down. Zinc sulfate. Green vitriol is iron, ferrous or ferric, iron sulfate, right? And now your blue vitriol is copper sulfate. Okay, now this reaction you can do it anyhow. Anyhow means the same method that we saw before. Okay, to produce copper sulfate, CuSO4. Okay, you need an acid which has SO4, which is an acid sulfuric acid, H2SO4. Okay, so that's how the SO4 comes. SO4 is from the acid, and the Cu is from anything that contains Cu. So you can take copper oxide, copper hydroxide, copper. So many are there. What all is there? Look here. Copper hydroxide, copper oxide, copper carbonate, copper sulfate. Copper sulfate, but we're already having sulfate, right? So if you take copper sulfate, you don't need to take sulfuric acid. You just have to take water. Okay, so obviously we're not using that because our aim is to produce copper sulfate, right? So this is the next step. Okay, that's the next step. Yeah, so don't take copper sulfate to produce copper sulfate. You can take copper oxide, copper hydroxide, or copper carbonate. Okay, so let us take, see, if you take copper hydroxide, you get water. If you take copper oxide also, you get water. If you take copper carbonate, you get water and carbon dioxide. Okay, so let's take the hardest reaction, that is copper carbonate, CuCO3. So Cu will join with SO4 to form CuSO4. H2 will join with CO3 to form H2CO3. What is H2CO3? Carbonic acid. But carbonic acid doesn't stay together. It is very volatile. It will separate into carbon dioxide and water. Okay. It is actually acid plus base, gives acid plus base, a more volatile acid. But this volatile acid is so volatile, we don't write it together. We have to separate it into carbon dioxide and water. Okay. Is that clear, everyone? Now, how does the reaction take place? First, you take sulfuric acid in a beaker. Imagine it, okay? We don't have a lab here, so take a beaker of what happened? Sulfuric acid, okay? Heat it on a wire gauze. So, put a stand and heat it. And then you add any of these salts to it. Salts or base, copper oxide, copper hydroxide, or copper carbonate. Keep adding little by little and keep stirring it. As you keep stirring, it will dissolve in it. And when it dissolves, it produces copper sulfate. This copper sulfate is not, it doesn't dissolve. It forms a precipitate. And so it settles to the bottom. Okay, once no more of the salt that you're adding is dissolving, you stop the reaction. Now to get the copper sulfate, what do you need to do? Just heat it. Keep heating it. So all the water will evaporate and you will get a hot supersaturated solution, and copper sulfate will be formed as crystals. Okay, that means the copper sulfate will join with water of crystallization. CuSO4 will join with H2O. How many H2Os? 5. Okay, joins with 5 water molecules to form CuSO4 dot 5H2. Okay, this is the blue color crystal. Have you seen copper sulfate? Have I showed you pictures of it? Yes? Yes, you have seen it. So blue color crystals, like sugar crystals, but blue in color. Okay. If anyone hasn't seen, yes, copper sulfate. Okay, blue color crystals. See here you have both the colors. So on the left side you have anhydrous copper sulfate, and on the right side you have hydrated copper sulfate. Anhydrous means just CuSO4, and hydrated means CuSO4 dot 5H2. Okay, is that clear, everyone?
Where do we use these crystals?
What?
Where do we use these crystals?
Why don't we use this test?
No, where do we use these crystals?
Oh, it's only for experiments. You never use it in real life. It's just for practical chemistry purposes. Okay, you try out something. Okay, it's a salt, but it's not a salt that we can eat. Okay.
Okay.
Okay, the last salt in this chapter, and this chapter is over. Okay, preparation of sodium sulfate crystals. Okay, write down this reaction before that. Okay, we'll go to the last salt, that is sodium sulfate with this 10H2O. That means hydrated, or water of crystallization is also present here. Okay, so to get this sodium sulfate, you need something that has sodium and something that has sulfate. So tell me, what has sodium? Our aim is to produce Na2SO4. Okay, so what has sodium? Something that has sodium. So you can take Na, NaCl or NaOH. Now depends what we are doing here. Okay, this what type of a reaction is this? It is a neutralization reaction. Okay, so which means you need an acid and a base. Okay, so NaOH. NaOH is the base. Yeah. And then you need an acid which has SO4. So H2SO4. Clear, everyone? So now Na will join with SO4 to form Na2SO4 and H2. Okay, reaction is very simple. The method used here is titration. Okay, do you know what's titration? Okay, so titration works like this. So first we will take a beaker containing NaOH. NaOH is a base. Now we add a drop of phenolphthalein to it. Now remember phenolphthalein. What is phenolphthalein? Okay, it's a common acid-base indicator. Yeah, and what is the color of what color will it turn now? You're putting it in base. So what color will it turn? Pink, right? Phenolphthalein is turns pink in a base, and in an acid, what color does it turn? Colorless. Okay. So right now you put this drop of phenolphthalein, the whole thing turns pink. So you know that it's a base. Okay. Now to that base, we're going to add sulfuric acid. How are we adding the sulfuric acid? Drop by drop. Okay. Look at this diagram over here. Okay. See in the beaker or this conical flask, you have sodium hydroxide, and drop by drop, we're adding sulfuric acid. Okay. Now you keep adding drop by drop because then it mixes nicely and evenly. And also, I think, okay, that's it. Now, how long do you keep adding these drops is till the color of the solution changes. It will become colorless. If it becomes colorless, it means all the base is gone. As long as the base was present here, the color will remain pink. But if the color turns colorless, if the pink goes, what does it mean is all the base has been is gone because it's reacted. It got neutralized. Okay. So what is in this now? What is formed? Sodium sulfate. But the sodium sulfate is also insoluble. It is dissolved in this. So how do you get the salt out now? Just the same usual way. Heat it, evaporate. Okay, let the water evaporate. Okay, so that way you're creating a hot supersaturated solution. And as the water evaporates, you will get crystals of sodium sulfate. That means this Na2SO4 will join with the water and form hydrated sodium sulfate or sodium sulfate with water of crystallization. Yeah, this is the formula for sodium sulfate. Yeah, it's written here. So Na2SO4 will join with how many molecules of water? 10 molecules of water to form Na2SO4 dot 10H2O. Write down the reaction. Okay, this chapter is over. There's a lot to study from this chapter. Okay, we studied about so many different concepts in this chapter. In acids, we just saw what an acid is, how an acid or what gives an acid its acidic properties. It is the number of hydrogen ions, right? The higher the concentration of hydrogen ions, the more stronger that acid is, right? So we saw different type of acids like monobasic, dibasic, tribasic acid, and how these acids they dissociate. Okay, how they give out their hydrogen ions to form different type of salts, right? Acid salts, normal salts. That's all we saw about acids. Okay, then bases, very similar. Okay, bases dissociate to give out hydroxide ion. Okay, whether a base has 2 or 3 hydroxide ions, it just dissociates it in one step, unlike acids which dissociates in different steps. That's all we saw about bases. Then salts, we studied too much about salts. We saw preparation of so many different type of salts and insoluble salts, soluble salts. Specifically, we studied 7 different salts and their methods of how to prepare them. Okay, so study this chapter well.